Hello. What's good? Yes. We are gonna be looking at Nvidia. I think chat should be coming through on the left side. What's up, guys? So let me know if how music is for you guys. I've got some shit blind. Is bro late? No, bro's not late. Yes, we're here. It is a pretty early morning for me, by the way. So mind me, the chat is not working, is it? Unless it's really delayed. Yeah, what's up, guys? What's up, Martin, Dr. Mortal? Yeah, I'm running on about 3 hours of sleep. So booger. Yeah, the chat isn't working on this side. I don't know why it's not working. Oh, now it's coming through. Now it's coming through. Okay, everybody's green today. Bro, YouTube is weird with this chat, bro. I'm not gonna show chat on the actual once the stream starts. By the way, how's the audio? How's the sound? Looks like I was coming in quiet or something. I don't know why, and I don't know how to change it. Imagine about they talk about AI the whole stream. Yeah. I'm ready for it, dude. I'm like so here for it. But your voice is what? Am I clipping? I don't know. Yeah, so here is the event. Confused Siren, how much do you think the 5090 will be priced at, by the way? Thanks for £2. That's pounds, right? I don't know. That's not real money, so. Honestly, I think the 5090 is gonna be over 2,000. Like easily. But yeah, here's the event. I don't exactly know what they're gonna be talking about here. They could announce something. I have no clue. Last year they announced the 4060 and the 4060 Ti at Computex, but they don't have that kind of stuff lined up right now. It's not like they already have another generation going right now, so I don't think they're gonna announce a graphics card. They might do the 5080 and 5090, who knows? But I doubt it. Sup, guard? Yeah, I don't know what they're gonna announce in here, but it's probably gonna be interesting to some degree. Their shit is always interesting. I wanted to show you, like, if you look up, it's so stupid. If you look up Nvidia on YouTube now, it's bad, guys. Like, look, it's just okay. There's us, and then they're also PC World's also live streaming the event. But a lot of this shit on YouTube now is just stock buying advice for Nvidia. You just look up Nvidia, it's just stock buying advice. It isn't like insane like views, but that's all people are talking about with Nvidia now. It is bad, bro. God. So I think at this event, probably the most thing that we'll get, I guess we get some graphics card stuff down here, I think the most we might get is maybe some features for games, maybe some technologies coming. I think that would be the most we're getting, but I don't know. It might just be AI. It's like a broken record. And also later today. Oh, by the way, I don't know if you guys saw this video I did yet. Oh, this is a good video though. I'm gonna look at this at some point. Lossless frame generation. Lossless scaling. But I have a strong feeling that we're not gonna be seeing anything that crazy. Who knows? I'd be surprised. Is there anything building up in the rumors? Let's check video cards. Give us framed in with 0 input delay. Now that would be crazy. They AI, like they use AI DLSS and they literally skip time. Get that to happen. Yeah, so later today as well, if we... I'm wondering if I'm gonna be able to stream this or not. Cause it's gonna be like an all day thing for me. Here's AMD is doing their event today as well. It's 9:30 my time, but it's, you know what I mean? It's like it's 9:30 my time, and this is 7 my time right now, 7 a.m. right now. So, but they're probably announcing Ryzen 9000 at this event, so this will be a big event. What's Computex? It's a big. We can look it up. Just so you guys get the rundown. Let's make sure everybody's on the same page. So this is an event. Nvidia is actually doing their conference a day before the event starts, as far as I know. I think they're doing it June 2nd on their time. I don't know. They're 12 hours ahead or behind me. I don't know what it is, but yeah, it's a big trade show in Taiwan, and basically Taiwan is where all the chips that we talk about, Nvidia, Intel, AMD, pretty much all the chips that we talk about are manufactured in Taiwan. So it's a big semiconductor area. So that's what we want. That's why it's in Taiwan, if you want a reference. And basically, it's just a big old event where a ton of stuff is announced. They're advertising the AMD announcement here. They're talking about the Snapdragon chips. Intel's gonna have an event. It is like it's a huge deal. AI. I think it'll be something like that. Apparently, I think I heard it from Moore's Law is dead. Jensen is apparently in the most relaxed state that people have ever seen him in. Like, he is like chilling. Obviously, Nvidia raking in the cash right now, but yeah, Jensen is like not stressed. This is the least stressed people have seen him in his entire life. Imagine Taiwan gets nuked and we never get a good price GPU. I don't think we ain't getting GPUs like ever again. There's actually some crazy stuff going on with because a lot of countries want to make sure that they can get manufacturing. There's stuff that with different. So like the U.S. is like trying to divide up semiconductor production, so it's in the US and also in Taiwan, and I think they're trying to bring some stuff to Japan, and I don't know, China's also trying to get into it. There's like tons of countries that are trying to get in on this, because if something does happen to Taiwan, yeah, we're screwed. We're very screwed. And those are the most advanced chips in the world, and they're gone. He said I don't know how to pronounce your name, but what is the best looking game in your opinion overall? God, bro. Let me check my Steam library. What do I have? Like just graphically, if we're talking about graphically the best game, but from a technical standpoint, I think Senua's Saga Hellblade 2 is probably the most graphically, technically impressive game of all time. But I'm not sure on the best looking game to me. There's certain games like, because I like art style a lot more. I really like the way Overwatch looks. See, even a game like Ori, this game looks beautiful and it's not that graphically demanding or anything. Elden Ring also looks good. You know, I haven't played Elden Ring though. I'm gonna need to play that. God of War probably looks good. I don't have that one. He's gonna crucify me not playing. Fucking Elden Ring. I mean, Avatar does look good. I don't want to play that game. I just get like so bored on it. What's up, Drizzy? Is that the real Drizzy? And that other game, like, I don't know. Dragon's Dogma 2 looked quite good. It had some visual bugs that annoyed me. Like, I didn't like how it did like scaling at every resolution. Like, it was always resolution scaling, and it made like chainmail and stuff in the game I thought looked weird. And they like fine detail, like the grass and stuff. I thought everything looked weird and fuzzy, but it did look good though. The effects were really cool. Other than that, I mean, Cyberpunk does look good too. No, nothing's happened to you quite yet. I think my phone is ringing. I don't think it is. It's chilling. Is there like rumbling? Do you actually want to play Elden Ring? No, I do want to play Elden Ring at some point. It's one of those games that I know I'm gonna get sucked into, and I'm gonna, oh god, like I'm not gonna want to stop playing it. There's games like that. Like right now, I'm playing through, even Last of Us Part 1 looks really good on PC, but like oh yo, we got a new member, Jensen supporter. I actually don't know what tier that is now. I don't use members that much, but thanks for joining, man. See, like I would get sucked into Elden Ring. I'm playing Last of Us, dude. I never played this game, and this game is so fucking good. Holy shit, it is so good. Is it the music? Can you guys hear the music or not? Did anyone watch Google I/O? Probably is. Boring. But man, I love Last of Us. This shit is so good, bro. It is crazy. Well, you guys have probably already played it though. Yeah, I have 34 minutes in Elden Ring, so I will probably at some time. In my S tier games, oh, well, so far Last of Us is an S tier game. I ain't gonna lie, that shit is crazy. Other games, dude, I love me Risk of Rain 2. This is an S tier game to me. I love this shit so much. And I love Terraria. I haven't played this in a while, but man, it's still an amazing game. And then, I mean, those are probably my S tiers. At least at the moment. Yeah, I'm trying to think of any other game. I don't know. What do you guys got any S tier games? I already played the Binding of Isaac. I played Rebirth. It's good. I like Risk of Rain better though. I also liked I just didn't think the game, like, eventually it ran out of like content to me, but Death Must Die. This is a roguelike as well. This was really fun, like really addicting. But at some point I just like kind of ran out of content. I was like 7 hours and I didn't know what else you're supposed to do. That I couldn't mix it up anymore, but it wasn't early access at the time, so maybe there's more content. Ghost of Tsushima seems fun too. I've played some of it. I'm not super deep into it. There's some aspects that I could see holding me back though. I don't exactly like running around so much in a game. It gets you immersed, but like you're running back and forth and back and forth. And Ghost of Tsushima, for sure. But it runs well too. It looks good, and it plays pretty well. And there's some depth to the combat. You're trying to like time things and all that shit. It's pretty fun. Dude, I made the thumbnail for this stream, like right before I went to bed, and I put one Nvidia on it, and I don't know why, but I thought when I was about to go to bed that Jensen's Wong, like Wong, you know, the Jensen Wong. I was thinking Wong was spelled like Juan, like Spanish Juan. I'm just gonna leave it, but I was so out of it, bro. What's up, David? Can you do a video about the most upcoming Unreal Engine 5 games? Is this gonna be caught up? Yeah, I don't really know. To me, like, the engine doesn't mean too much to me. Cause I'm trying to have we seen a genuinely fun Unreal Engine 5 game yet? I mean, Power World was an Unreal Engine 5. I get a lot. There's a lot of stuff about. I made that Senua's Saga Hellblade 2 video. A lot of people did not like my take on that game. That was interesting. Yeah, I mean, I don't really know any Unreal Engine 5 games that are coming up, if I'm being honest. Unity. Unity. Dude, Unity almost self-combusted last year. That would have been wild. And I don't even know if it's doing that good right now either. Yeah, but people didn't like the Senua's Saga Hellblade 2 take because my argument was that the game focused too much on the technical standpoint. And I think I'm going to turn out, I'm going to be right. I'm going to be right on this. Like, it focuses so much on the technical standpoint of the game that like so much of the budget and time and effort got put into that, and then they ended up just basically making the same game again to some degree. Like, I don't think it went too much more in depth than the first game, and it's just, I don't think people want to play that. It's like trying to be like an art piece before a game. Yeah, I'm not sure if that game's gonna sell well. I wish them the best because I think there's a lot of talented people over there, but let's see how it goes. Is there fighting in Hellblade 2? Actually, people said they didn't like the combat in Hellblade 2, but I liked it. I thought it was fun. Now, like, apparently it was about the same as the combat in the first game, so that was the difference, I guess. I didn't play the first game, but the combat in the second game, I thought it was fun. It looked cool too. The only problem is they don't give you that much time to react to things. So, like, oh god, let me see if I can pull up gameplay for you guys. Okay. So, like, this was me playing the game. it's just I thought there's way too much time in between combat, and actually playing the game was just boring. But like the combat was pretty fun. But like when you need to do a different variation of either a parry or a dodge or an attack to try to throw off the person you're fighting. It's like rock paper scissors. But I don't think they give you enough time or like enough buffer to do what you want to do. I end up getting hit a lot, and I don't think it's a skill issue. Like I just think you have a really, really small amount of time. Like there, I get it. And like I got hit there. That was probably me just not knowing his attack pattern though. Sometimes you get in a flow state, but there's like a difference. Like I thought in if you guys have played Stellar Blade, obviously that's still on. Yeah, it's their stream starts in about 7 minutes here. If you guys played Stellar Blade on PS5, I thought that game had a really good like parry timing and stuff. So, what game is this? This is Hellblade 2. Yeah, but it's cool though. I liked it. I like that combat. And Nvidia's stream is starting in 6.5 minutes. Stellar Blade is a game first, not tech demo. That shit is fun, bro. The thing is, like, at least most people in chat here, I feel like you don't have a PS5. I don't have a PS5 either. I had to go over to a friend's place. What are we expecting from this keynote? I don't think we're expecting much, guys. But, you know, I want to watch it with y'all. Because if there is something, you know? Is it? Levin said, I have a serious issue with my Dell laptop and the customer service isn't helping me. Dude, I can't help you, bro. Sorry. I hope you can get it fixed, but I can't help you, bro. Maybe at that point you might as well do all the advice that Gamers Nexus talked about with Asus. FrameGen 2.0. You know, they're gonna probably introduce last generation they announced frame generation alongside the new GPUs, like 40 series. So I have a feeling that they're not gonna be announcing DLSS technology alongside this, but maybe they introduce a frame generation technology that gives you 3 times the frame rate, because that's possible. I mean, they can just, once they have the first frame and the second frame, they can interpolate really as many frames as they want in between them. So I don't know. The only thing is I haven't had that much like luck with frame generation technology. Like if I'm running it in a game and my game's like maxed out, I don't get like double the frame rate. I get like about 30 to 40% more frame rate from DLSS and FSR3. It just isn't good. I mean, it is good, but it's not that crazy. Did I play Valorant? No, I played a little bit of Valorant. The only shooter I got into was Overwatch. I was addicted to Overwatch. And that was in about, what, 2021? No, wait. No, what year was that? That was about 2022. Going in 2023, I was addicted to Overwatch. It was fun, but just, dude, there's something like with shooters and stuff, it's just, they're fun as hell. It's cool to improve your skill and everything. But then, once you get into it and you're actually climbing in the game, is like, are you seriously gonna put in enough time to be better than the other players to climb? Like there's always gonna be somebody who puts in more hours than you. It just felt like a waste of time. It's like, I'm not gonna be better than these people. I don't even want to be better than these people, so I'm just gonna play other stuff. But I don't know, bro. Expect to sell one of my kids for a 5090. Yeah. Play TF2. Nah, I don't want to play TF2. I remember playing that on integrated graphics on a laptop. Probably at like 20 FPS. I mean, I like playing games that, it could even be cooperative games. Like, I feel like I'd like Helldivers and stuff. Because, I want a challenge, but I don't really want anything competitive, because I'll be competitive on other stuff. Okay, the Nvidia's starting there. It isn't their stream, but they have some music. Okay, last time I played the music at the beginning of their stream, it was copyrighted. We're gonna see when it starts. I'm gonna just turn it down until it starts. I'm excited for Zen 5, my upgrade this year. I mean, Zen 4 is great. I mean, the 7800X 3D is great. I can't really say anything about the other ones. But, man, they're announcing what I would assume is Zen 5 later today. At least for me. It might be tomorrow for some people. Helldivers is amazing, yeah. I'd probably like it. Because that's one of the reasons I like Risk of Rain a lot, because I grew up playing like Call of Duty Zombies and stuff, and Risk of Rain, like I was just like realizing, I was like, oh damn, this is like upgraded zombies, and I like love that. I need more coffee. Waiting for Zen 7. Bro, there's people that haven't upgraded GPUs in so long. Do they know that this is cut off on the side? I don't think this is on me. It's like cut off. There we go. By the way, when the stream starts, I'm gonna turn down. Oh, I'm gonna turn off the music. I expect a battle mage reveal for Intel. I mean, they could. I don't know when the Intel event is. When is Intel at Computex? When is this? It's 1 day, 16 hours away. Maybe I'll be able to stream that too. I don't know what they're going to announce. I mean, maybe Lunar Leak is going to be coming on the CPU side, and I would hope Battle Mage is getting announced at some point, because it is supposed to come Q2. So, it's been delayed. Did you try Microsoft Auto's Super Resolution yet? You can't try it yet. You need a Snapdragon chip. I'll try it when it comes out. I'm tired of this AI shit. Yeah, I don't have a Snapdragon chip. I mean, I want to test the Snapdragon chips anyways when they come out. They're just not out yet. I'll have to get a laptop. How long Computex stream? I don't know how long their stream's gonna be. Are you buying the 5090? Bro, I ain't buying that shit. Dude, I do this like semi-professionally. Like content creation for GPUs and stuff. Bro, I ain't buying a 5090. And that tells you, God, this shit is so expensive. And that's the thing, is like, it's gonna be not the fastest GPU in about 2 years. So I don't get buying the latest gen tech. I don't need it either. Do you play any Pokemon games? I mean, I use the music all the time because Black and White's my favorite Pokemon game. I stopped playing at Gen 6 though. Unless you have 4K, it's pointless. I don't even think you need a 4090 for 4K. I mean, a lot of my GPUs can handle 4K. You just gotta use a little bit of scaling. I mean, Nvidia's doing like, this is like a pre-stream thing. I don't know when it's actually gonna start. Wait, the Ally X came out? Wait. Linus has a video on it. I'll have to check that out later. Comments turned on. They're usually turned off. There's very rare like company streams, like big corpo streams that have comments on. Comes out mid-July. How is my stream so smooth? At 60 FPS, that's all. You have a 4K card today, 2 years, it'll probably not do 4K. I mean, that's pretty much what it is, yeah. Yeah, I mean, a lot of the... To be honest, if you're playing at 4K, I just don't know why you would be using ray tracing. I would just... It's gonna be so much better if you don't use ray tracing at 4K. I don't know. If you want literally the bleeding edge, highest resolution, best graphics, then cool, go for it. But I don't know why. Like, especially at 4K, I'd be making compromises and get a cheaper GPU. I love ray tracing. 8K. Dude, there's a huge push for 8K, and I don't know who the hell is ever going to be using 8K, bro. It's not really even that useful, because even in like a big screen, you know, in your living room type of setting, 4K is still pretty good at that size, that TV size. Now, like 8K is better, but man, the bit rates, the graphics, the tech, like the hardware you have to push 8K, it just does not. It sounds so pointless, bro. We've already peaked at 4K, I think. There's not even a difference between 4K and 8K. I would have to see it in person for myself. What's your favorite game you've played? Probably my favorite game of all time is probably Risk of Rain 2. That game is so much fun. I love it. But I mean, like, dude, like a close second is like Minecraft or Terraria. Like those are fun, bro. Try Gunfire Reborn. What is that? Although I have to play Risk of Rain 2 with some mods, some quality of life mods. Yeah, I'll go talk to Jensen real quick and I'll get them to start a little bit faster. Like, we have some people waiting here. Come on, Jensen. Most hours on game on Steam. I think it's Terraria. I have like 500. I've been playing that since like... God, when did I start playing that? Like 2014 or something? Think about Dishonored 1 and 2. I like Dishonored 1 better, but... those are great games. They're not my favorite games ever, but they're great games. There's always stuff to do. Yeah, I don't exactly have like insane hours on games, but I've played quite a few games. No, they haven't started the stream yet. I think on like off of Steam, I probably have close to 300 hours in Fortnite and probably close to 300 hours in Overwatch 2. And then Minecraft, God. I probably have more than 500 in that game. Will the 5090 be announced today? I don't know. I doubt it. They didn't do... Like, that... They usually line up their GPUs to launch around 2 months... I don't know. Usually about 2 months after the announcement or a month after the announcement. So, I think they'd be aiming for, like, fall for the new GPUs. And 2 months isn't going to line up with that. It just doesn't make sense to me. It could happen. I'd be surprised. But they also probably would have hyped up this event more than what they have. You know, 400 hours in Rocket League. I never got into Rocket League. Can't you basically play Rocket League in Fortnite now? Am I crazy? What kind of Minecraft player are you? When I played Minecraft, I would basically be the technical guy who makes farms all the time. I didn't really care what my shit looked like. I didn't care about PvP. I just wanted to maximize production and enslave all of the Minecraft world. That's basically what I did. I like some modded, like I like Sky Factory a lot. Yeah, 2,000 hours in Overwatch. What rank are you? Do you play on a TV or a monitor? I play on a monitor. It's a 32-inch monitor, 1440p. Some people don't like the, 1440p 32 inches. I'm telling you, bro, it's fine. Some people get scared of it. It's like, it could be a little bit sharper, but I can't see pixels on it. RLCraft was the funniest Minecraft mod I played. Yeah. I didn't get into that. I didn't know how to start RLCraft, so I just didn't bother. There's a spider climbing up my wall. I played Genshin for 560 hours to find out the game is shit. What's the fastest GPU you've used? I mean, I'm on it right now. I'm on the 4080 Super. That's the fastest card I've ever used. Yeah, if I end up getting a 5090, the only way I'm getting one is probably if Nvidia sends me one. And to be honest, I just think about that, and they send out review samples, and I'm like, dude, holy shit, they're sending out, I mean, it doesn't cost them $2,000 for a GPU, but, they're sending you $2,000 GPUs for reviews. That's nuts, bro. Yeah, but the 4080 Super is really fast. I also have the 7900 XT, which is pretty fast as well. Get sponsored and get a 5090. But you can't say bad things about it. I mean, on the reviews, they don't sponsor you, bro. Nvidia got in big trouble for trying to influence reviews. And if you talk to them, you can be pretty much, I mean, I don't know, maybe they don't like it. I still talk to the rep at Nvidia. I don't know. I'm pretty negative about what they've done, so they seem to be okay with it, though. Do you think AMD actually stopped trying to compete at the high end? I think so. I mean, all the rumors are pointing to it. At least this generation. Next one, I don't know. They might be up there again. What I hate about AMD's strategy is, bro, they're so inconsistent. It's like 1 year, they got a whole bunch of shit, and they're competing very heavily on performance. Next year, it's like, oh, too bad. It's like, being someone who buys an AMD is way too inconsistent. Also, the screen went black. Ooh. Here we go, boys. All right, let's check it.
Good take, good take.
Here it is.
Okay, you guys ready? Yeah. Everybody thinks we make.
How's audio? Let me know on audio.
Nvidia is so much more than that. This whole keynote's going to be about that.
Okay, so we'll start at the top.
Examples of the use cases and then seeing it.
Jensen do it in the kitchen.
It's such a compelling story.
Just tell me if I'm too loud or anything on it.
Get in the rhythm.
We're 2 weeks away from it. You guys can go really.
I can only turn myself down. I can't turn them up.
Yeah, that's the plan. I think we need to get daily status on that animation.
Can you mute? Because I hear myself.
Sorry.
What's the drop date for all the videos? It needs to be done on the 28th.
Did you get all
I'm just
that?
turning down my voice a little bit, by the way. Let me know.
Safe travels, everybody.
Super excited to see everyone.
See you guys soon. Okay. Bye. Bye.
Well, their stream is as loud as it can go.
We're basically moving as fast
I
as
could
the world can
push it up
absorb technology,
somehow. I just don't
so
have an
we've
easy
got
way to
to
do it right
leapfrog
now.
ourselves in rent. Now the spine, you just have to figure out a way to make it pop. You know what I'm saying? You know what I'm saying? You want to, yeah, that kind of thing.
It seems like their stuff is quiet though. It's only coming at like 15 dB.
Thank you. I'm super late. Let's go.
Is this live?
Please welcome to the stage Nvidia founder and
'Cause it's actually a no.
CEO Jensen Wong.
Or no? Holy shit, dude, the production's cool.
I am very happy to be back. Thank you, NTU, for letting us use your stadium. The last time I was here, I received a degree from NTU.
I'm gonna try to turn them up.
And I gave the run, don't walk speech. And today we have a lot to cover. So I cannot walk, I must run. We have a lot to cover. I have many things to tell you. I'm very happy to be here in Taiwan. Taiwan is the home of our treasured partners. This is, in fact, where everything NVIDIA does begins. Our partners and ourselves take it to the world. Taiwan and our partnership has created the world's AI infrastructure.
Is that better?
Today, I want to talk to you about several things.
Yeah, just, they should be louder.
One, what is happening and the meaning of the work that we do together? What is generative AI? What is its impact on our industry and on every industry?
Guys, this might be an AI
blueprint for how we will go forward and engage this incredible opportunity. And what's coming next?
Guys, AI.
Generative AI and its impact, our blueprint.
I mean, our hope is that they introduce something.
These are really, really exciting times.
That isn't just about
a restart of our computer industry.
It's something they can apply to gaming.
An industry that you have forged, an industry that you have created, and now you're prepared for the next major journey.
Sometimes they do.
But before we start,
remember, DLSS was an AI feature.
NVIDIA lives at the intersection of computer graphics, simulations, and artificial intelligence. This is our soul. Everything that I show you today is simulation.
I will
it's
say
math,
like
it's science.
Of all the CEOs that get up and talk,
it's amazing computer architecture.
Jensen is cool.
None of it's animated, and it's all homemade. This is NVIDIA soul.
A lot of CEOs are just awkward and
put it all into this
like
virtual
weird.
World we call.
But Jensen is
Omniverse.
actually cool.
Please enjoy.
It's still CEO though. There we go. So this is that's crazy. Is this their God, what's that thing called? Where like simulates it? Didn't we say the sim trailer before? I'm pretty sure we did. Omniverse. It's because they put all their technologies into one place and made like a simulated reality, basically. Apparently, it's really useful. It's just I don't know. It's like yeah, you could design like a factory inside of Omniverse. Video is so loud. Yeah, it's gonna be hard to manage their stuff. Turning it down. Because Jensen's quiet, and then this is loud. I'll have to turn it back up when Jensen comes back on. My bad. Yeah, turn it back up. What language is that? Is that Taiwanese? Skynet.
I want to speak to you in Chinese, but I have so much to tell you. I have to think too hard to speak Chinese.
Taiwanese a language?
So I have to speak to you in English. At the foundation of everything that you saw was two fundamental technologies: accelerated computing and artificial intelligence running inside the Omniverse. Those two technologies, those two fundamental forces of computing are going to reshape the computer industry. The computer industry is now some 60 years old. In a lot of ways, everything that we do today was invented the year after my birth, in 1964. The IBM System 360 introduced central processing units, general purpose computing, the separation of hardware and software through an operating system.
What's interesting though is they're showing that, but they don't show it.
IO
Nvidia
subsystems,
integrates
DMA,
into that yet. I mean, they're going to talk about it later.
All kinds
but
of technologies that we use today.
iPhone was
architectural compatibility, backwards compatibility, family compatibility. All of the things that we know today about computing largely described in 1964. Of course, the PC revolution democratized computing and put it in the hands and the houses of everybody. And then in 2007, the iPhone introduced mobile computing and put the computer in our pocket. Ever since, everything is connected and running all the time through the mobile cloud. This last 60 years,
they don't put the Samsung phone
we
up
saw
there.
several.
That's crazy.
Just several, not that many actually, 2 or 3 major technology shifts. 2 or 3 tectonic shifts in computing.
Guys, remember when computers used to be the size of a room?
And we're about to see that happen again.
No, I don't remember that.
There are 2 fundamental things that are happening. The first is that the processor, the engine by which the computer industry runs on, the central processing unit, the performance scaling has slowed tremendously.
Yeah, it's slowing down.
And yet, the amount of computation we have to do is still doubling very quickly, exponentially.
He is right about that.
If processing requirement, if the data that we need to process continues to scale exponentially, but performance does not, we will experience computation inflation. And in fact, we're seeing that right now as we speak. The amount of data center power that's used all over the world is growing quite substantially.
Dude, you know
the cost of computing is growing. We are seeing computation inflation.
Buying an entire server system.
This, of course, cannot continue.
And then it being irrelevant in about 2 years.
The data is going to continue to
or like just completely outclassed by new tech.
And CPU performance scaling will never return. There is a better way. For almost 2 decades now, we've been working on accelerated computing. CUDA augments a CPU, offloads and accelerates the work that a specialized processor can do much, much better.
Well, that's the thing is that you say
In fact,
inflation.
the performance is so
or
extraordinary
the prices are
that
raising.
it is
And
very
that's his
clear
fault.
now, as
I mean, it's
CPU
happening to
scaling
every
has
single
slowed
chip
and
maker. So
substantially stopped, we should
is it really
accelerate
Jensen's
everything.
fault?
I predict
They're probably
that every application
they're
that
probably
is processing intensive will be accelerated.
more
and
expensive than they
surely
should be, but
every data center will be
every
accelerated
company's
in the near
going
future.
through the same thing.
Now, accelerated computing is very sensible. It's very common sense. If you take a look at an application, and here the 100T means 100 units of time. It could be 100 seconds, it could be 100 hours, and in many cases, as you know, we're now working on artificial
what if we do see an
intelligence
Nvidia
applications
CPU on
that
this
run
one?
for 100 days.
Might happen.
The 1T is code that requires sequential processing, where single-threaded CPUs are really quite essential. Operating systems, control logic, really essential to have one instruction executed after another instruction. However, there are many algorithms, computer graphics is one, that you can operate completely in parallel. Computer graphics, image processing, physics simulations, combinatorial optimizations, graph processing, database processing, and of course, the very famous linear algebra of deep learning. There are many types of algorithms that are very conducive
at the same level as them.
to acceleration through parallel processing. So we invented an architecture to do that by adding the GPU to the CPU.
Yeah,
a
we know this.
specialized processor can take something that takes a great deal of time and accelerate
I feel like
it
this
down
is something
to
that he would have
that's
explained about
incredibly fast. And because the two
10 years ago.
processors can work side by side,
This
they're
isn't
both
that crazy.
autonomous and they're both separate, independent.
I mean,
that
he
is,
might just be setting the
we could
groundwork.
accelerate what used to take 100 units of time down to 1 unit of time. Well, the speed up is incredible. It almost sounds unbelievable. It almost sounds unbelievable. But today I'll demonstrate many examples for you. The benefit is quite extraordinary. 100 times speed up, but you only increase the power by about a factor of 3. And you increase the cost by only about 50%. We do this all the time.
Only
in the
about
PC industry.
50%.
We add a GPU, a $500 GPU, GeForce GPU, to a $1,000 PC, and the performance increases tremendously. We do this in a data center. A $1 billion data center, we add $500 million
You just say
worth of
$1 billion,
GPUs,
bro.
and all of a sudden it becomes an
Yeah,
AI
bro, I'm
factory.
about one of those. Easy.
This is happening all over the world today.
I
Well,
just need a small loan.
the savings are quite extraordinary. You're getting 60 times performance per dollar.
Someone just said
100
he's going to
times
be
speed
bald,
up.
bro. The money Jensen's got, no, he
You only
ain't going
increase
to
your
be
power
bald.
by 3x, 100 times
Somebody
speed
got to
up,
figure that out for him.
you only increase your cost by 1.5x. The savings are incredible. The savings are measured in dollars. It is very clear that many, many companies spend hundreds of millions of dollars processing data in the cloud. If it was accelerated, it is not unexpected that you could save hundreds of millions of dollars. Now, why is that? Well, the reason for that is very clear. We've been experiencing inflation for so long in general purpose computing. Now that we finally determined to accelerate, there's an enormous amount of captured loss that we can now regain. A great deal of captured, retained waste that we can now relieve out of the system, and that will translate into savings. Savings in money, savings in energy. And that's the reason why you've heard me say, the more you buy, the more you save.
Hey. The crowd likes.
And now I've shown you the mathematics. It is not accurate, but it is correct.
Guys, remember, the more you buy, the more you
That's
save.
called CEO math. CEO math is not accurate, but it is correct. The more you buy, the more you save.
That's crazy.
Well,
That's
accelerated
crazy.
computing does deliver extraordinary results, but it is not easy. Why is it that it saves so much money, but people haven't done it for so long? The reason for that is because it's incredibly
I thought
hard.
you said meth too. Well, am I crazy?
There is no such thing
I know you
as
said
a
math,
software
but
that you can just run through
it
a
sounded
C
like math.
compiler, and all of a sudden, that application runs 100 times faster. That is not even logical. If it was possible to do that, they would have just changed the CPU to do that. You, in fact, have to rewrite the software. That's the hard part. The software has to be completely rewritten so that you could refactor, re-express
basically what he's saying here is that everything is written for
the
CUDA.
algorithms that was written on a CPU, so that
And
it
that's
could
one of the
be
reasons why AMD is such a hard time
accelerated,
catching up
offloaded,
now, because they
accelerated,
don't have
and
that
run in
infrastructure.
That computer science exercise is insanely hard. Well, we've made it easy for the world over the last 20 years. Of course, the
And
very
CUDA
famous
is-
CUDA,
I don't really
the
use
deep
CUDA
learning
that much,
library
but-
that processes neural
I mean, I
networks.
use CUDA,
We have
but
a library for AI physics.
by the way, they have a
that you
little
could
thing in
use
the
for
corner.
Fluid dynamics and many other
He's down here,
applications,
little
where the neural
Jensen there.
network has to obey the laws of physics.
I use
We
CUDA,
have
but
a
it's
great
not
new library called Ariel
as extensively as a
that is
business
a
would.
CUDA accelerated 5G radio, so that we can software define and accelerate the telecommunications networks the way that we've software defined the world's networking internet. And so the ability for us to accelerate that allows us to turn all of telecom into essentially the same type of platform, a computing platform, just like we have in the cloud. cuLitho is a computational lithography platform
He just
that
ate his
allows
mic
us
for a second.
to process the most computationally intensive parts of chip manufacturing,
By the way,
making the mask.
He is
TSMC
yapping,
is
but
in
at the same
process of
time,
going to production with
expect
cuLitho,
this
saving
is
an
probably
enormous
like at
amounts
least
of
an hour and a
energy
half
and
presentation.
enormous amounts
I would
of
think.
money, but the goal for TSMC is
I don't
to
know what he's building up to.
accelerate their stack so that they're prepared for even further advances in algorithm and more computation for deeper and deeper, narrow and narrow transistors. Parabricks is our gene sequencing library. It is the highest throughput library in the world for gene sequencing. cuOpt is an incredible library for combinatorial optimization, route planning optimization, the traveling salesman problem, incredibly complicated.
What is combinatorial?
Scientists have largely concluded
Okay.
that you needed a quantum computer to do that. We created
I'm gonna
an
need AI to
algorithm
read that
runs
for
on
me.
Accelerated computing that runs lightning fast. 23 world records. We hold every single major world record today. cuQuantum is an emulation system for a quantum computer. If you want to design a quantum computer, you need a simulator to do so. If you want to design quantum algorithms, you need a quantum emulator.
Whatever
to do so.
happened to
How
quantum?
would you do that? How would you design
Th-
these
like,
quantum computers?
I know it's very,
create
very
these
hard to set
quantum
up
algorithms,
and
but the
very
quantum
expensive.
computer doesn't exist. Well, you use the fastest computer in the
I remember
world that
them
exists
talking
today.
about it like
We
5, 10
call
years
it,
ago.
of
I don't.
course, Nvidia CUDA. And on that, we have an emulator that
Is it ever
simulates
gonna
quantum
happen?
computers. It is used
It's just being developed.
several 100,000 researchers around the world. It is integrated into all the leading frameworks for quantum computing, and is used in scientific supercomputing centers.
I feel like there's
all
going
over
to be
the
a
world.
point at some point in
QDF
time where we're
is
probably
an
going to need
unbelievable
quantum computing.
library for data processing. Data processing consumes the vast majority of cloud spend today. All of it should be accelerated. QDF accelerates the major libraries used in the world. Spark, many of you probably use Spark in your companies. Pandas,
Pandas?
a new one called Polar, and of course,
Oh, yeah, we use that
network
stuff all the
access, which is a
time, yeah.
graph processing.
Yeah.
database,
Yeah, for sure, for sure.
Library. And so these are just some examples.
So
There's
naming
so many more.
the 0 things that
Each
you
one
guys
of
use
them had
AI
to be
for.
created so that we can enable the ecosystem to take advantage of accelerated computing. If we had
I will say, I know
created
crazy moment.
CUDA
I
alone
used
would have
AI.
been able-
I mean, he doesn't even
would
talk
have
about
been possible for all
AI
of the deep
quite
learning
yet. Now he
scientists
kinda
around
is,
the
I don't
world
know.
to use.
But
Because CUDA
for the
and the
thumbnail of
algorithms
the
that are
live
used
stream, I did
in TensorFlow,
upscale an
PyTorch, the
image
deep
of
learning
Jensen
algorithms,
through an
the
AI
separation is too far
upscaler.
apart.
I know,
It's almost like
crazy.
trying to do computer graphics without OpenGL. It's
But
almost like doing data processing
that's what I
without
did.
SQL. These domain-specific libraries are really the treasure of our company. We have 350 of them. These libraries is what it takes and what has made it possible for us to have such open so many markets. I'll show you some other examples today. Well, just last week, Google announced that they've put cuDF in the cloud and accelerate pandas. Pandas is the most popular data science library in the world. Many of you in here probably already use pandas. It's used by 10 million data scientists in the world. Downloaded 170 million times each month.
What are they talking about?
It is the
science?
Excel.
Like
It is
what
the
kind of data
spreadsheet
scientists?
Of data scientists.
What is a
Well,
data scientist?
With just one click, you can
Like I
now
kind of get
use
it and I kind of don't get it.
pandas
What do they do?
Colab, which is Google's cloud data centers platform, accelerated by cuDF. The speed up is really incredible. Let's take a look.
Yeah, I'm gonna turn it down. I love these. Like, is it actually that much
That was a
faster? Or is
great
it
demo,
just
right?
like?
Didn't take long.
That's kind of funny though. But just like arbitrary graphs and tests.
When you accelerate data processing that fast, demos don't take long. Okay, well, CUDA has now achieved
Yeah, we coding.
what people call a tipping point. But it's even better than that. CUDA has now achieved a virtuous cycle. This rarely happens. If you look at history and all the computing architectures, computing platforms, in the case of microprocessors, CPUs, it has been here for 60 years. It has not been changed for 60 years. At this level,
I'm
this
wondering if
way
I don't
of
think we
doing
ever will,
computing,
but is
accelerated
there ever going to be a
computing,
point when we don't
has been
have
around, has
CPUs?
creating a new platform is extremely hard because it's a
And there's
chicken
something that
and egg
accelerates
problem.
everything.
If there are no developers,
I feel like
that
you
use
always
your
need a
platform,
CPU just in case you
then
need
of
it. You know?
course there will be no users. But if there are no users, there are no install base. If there are no install base, developers aren't interested in it. Developers want to write software for a large install base. But a large install base requires a lot of applications so that users would create that install base. This chicken or the egg problem has rarely been broken. And it's taken us now 20 years, one domain library after another, one acceleration
CPUs are good
library
for single
another,
thread stuff,
and
which is a
now
lot of
we
stuff
have
that we
5
do.
million developers around the world.
I used upscaly.
We serve every single industry.
You can look it up.
from
It's
healthcare,
not
financial
spelled
services,
like
of course, the
upscale. It's
computer
like
industry,
I don't
automotive
know.
industry,
It's spelled weird,
just about
but
every major industry
you can find
in the
it.
world,
It's free.
just about every field of science.
It works well.
Because there are so many customers for our architecture, OEMs and cloud service providers are interested in building our systems. System makers, amazing system makers like the ones here in Taiwan are interested in building our systems, which then takes and offers more systems to the market, which of course creates greater opportunity for us, which allows us to increase our scale, R&D scale, which speeds up the application even more. Well, every single time we speed up the application, the cost of computing goes down.
I'm kind of lost what the hell he's saying right now.
This is that slide I was showing you earlier.
He really is
100x
the
speed up
yapper.
translates to 97, 96%, 98% savings.
I doubt we're
And
getting
so
new
when we go from
GPUs.
100x speed up to
There might be
200x
something,
speed
though.
up to 1000x speed up, the savings, the marginal cost of computing continues to fall. Well, of course, we believe that by reducing the cost of computing incredibly,
This is the thing is they just did a
the
big
market, developers,
announcement
scientists,
and conference
inventors will
pretty
continue
recently
to discover new algorithms that consume
March.
more and more and more computing, so that one day something happens, that a phase shift happens, that the marginal cost of computing is so low that a new way of using computers emerge. In fact, that's what we're seeing now. Over the years, we have driven down the marginal cost of
Is this the
computing
same leather
in
jacket?
the last 10 years in one particular algorithm by 1 million times. Well, as a result, it is now very logical and very common sense to train large language models with all of the data on the internet. Nobody thinks twice.
Dude, there's
This
like
idea
controversy with that
you
shit.
could create a computer that could process so much
Is it
data
like them just
to write its own
stealing
software.
everything?
The emergence of artificial intelligence was made possible because of this complete belief.
I don't know if
that
to
we
announce
made
something for gamers.
computing cheaper and cheaper and cheaper, somebody's going to find a great use. Well, today, CUDA has achieved the virtuous cycle. Install base is growing. Computing cost is coming down. which causes more developers to come up with more ideas, which drives more demand. And now we're in the beginning of something very, very important. But before I show you that, I want to show you what is not possible if not for the fact that we created CUDA, that we created the modern version of the modern
I wonder
Big
if
Bang of
Nvidia
AI,
wasn't the one to
generative
create
AI,
CUDA, who would have made
what
it?
I'm about to show you would not be possible. This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we
They're
can change our
simulating the
habits now.
entire Earth.
This digital twin of Earth is probably one of the
I can
most
put some
ambitious
subway
projects
surfers on the side here.
that the world's ever undertaken, and we're taking large
Guys,
steps every
they made
single
Earth
year,
too.
and I'll show you results every single year. But this year we made some great breakthroughs. Let's take a look.
It's gonna be loud. Not yet. Omniverse simulations.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
Inverted umbrellas.
想象一个我们能够预测
I don't
未
think
来
it's
的
that
世
loud.
界，数位孪生反映真实情况的虚拟世界，让我们看见未来。数位孪生是一种反映真实世界的虚拟模型，
That is cool,
让
though.
我们能
So
够
this
从
is
今天的
simulated.
行为来预测对未来世界的影
This
响。
isn't. Is it real time? I have no clue if it's real time. I kind of doubt that.
介绍一下 Nvidia Earth 2，一个利用 AI、
Nvidia
物理
made
模
Earth
拟
2.
和电脑图形技术来预测全球气候的数位孪生。Core Diff 是 Nvidia 的生成式 AI 模型，它在 WRF 数值模拟的基础上训练
But it
而
makes
成，
sense in
能够
Chinese,
以
but
12倍更高的
didn't
解
expect
析
it.
度生成天气模式，从25公里提高到2公里，这代表了区域天气预测的一个巨大飞跃。令人惊讶的是 ，Core Diff AI 比传统的物理模拟方法快1000倍，且
Does
能源效
Nvidia
率高
actually do this,
3000
or
倍。
did they say who does this?
在台湾的中央气象局是用这些模型来更精确地预测台风登陆点。但我们并不止步于此，下一个前沿是超本地预测，
Holy
能精确
shit!
到数十米，
That's
并考虑
simulated.
到城市基础设施的影响。
What the?
Core Diff AI 还在使用像是 Palm 生成的高解析度
Dude, that's
数据进行训练，一个
That's
极高解析度
wild.
的
They
物
can
理模
simulate
型
the air patterns.
用于模拟大气和海洋边界层。当与天气模拟风场结合一起时，它可以模拟建筑物周围的气流。当极强风汇聚的情
This
况，
doesn't surprise
我
me,
们预
but
计
it's
能
cool
够预
as
测
hell.
像下冲这样的现象。当强风汇聚到街道
So
层，
basically,
会有
Nvidia's like
可
God.
能造成损坏并影响行人。Nvidia Earth 2是一个绝佳范例，它融合了人工智慧、
Just the
物
way
理
he
模拟
says it.
和观测数据，可以帮助国家和公司预见
Oh my
未来
God.
并应对极端天气的影响。
This is cool. Now, how are they doing that for every location on Earth? I have no clue.
Someday in the near future, we will have continuous weather prediction at every square kilometer on the planet. You will always know what the climate's going to be. You will always know.
Okay.
And this will run
So you're
continuously
saying that's the goal?
because we've trained the AI.
Yeah,
And
can we
the
play
AI
Earth
requires
2
so
with
little energy.
path tracing, please?
And so this is just an incredible achievement. I
When
hope
is
you
this
enjoyed
patch
it.
coming out?
And very importantly, 我的国语讲的标准吗？ The truth is that was a Jensen AI. That was not me. I wrote it But an AI, Jensen
Oh.
AI, had to
That
say
didn't
it.
sound like him at all. I didn't think that was him. What the hell? No, the stream's buffering. No.
Because of our dedication to continuously improve the
I don't know what
performance
happened.
of drive the cost down,
We're here.
AI researchers discovered CUDA in 2012. That was Nvidia's first contact with AI. This was a very important day. We had the good wisdom to work with the scientists to make it possible for deep learning to happen. And AlexNet achieved, of course, a tremendous computer vision breakthrough. But the great wisdom was to take a step back and understanding what was the background, what is the foundation of deep learning? What is its long-term impact? What is its potential? And we realized that this technology has great potential to scale. An algorithm that was invented and discovered decades ago, all of a sudden, because of more data,
I don't even.
larger networks, and very importantly, a lot more compute.
I would
all
hope
of a sudden,
at some
deep
point we
learning
can
was
get to
able
a day where we
achieve
could simulate
what
Earth.
No human algorithm
And then we
was
just
able
live
to.
in the simulation and we don't live in
Now
real life.
imagine
There you go.
if we were to scale up the architecture even more.
Yeah, pretty
Larger
much
networks,
Matrix.
more data and more compute.
How many
What could be
H1000s do we need
So
to,
we dedicated
or
ourselves
H100s?
to reinvent
Do we need to do that?
everything.
Just a few, right?
After 2012, we changed the architecture of our
100,000 of them.
GPU to add tensor cores. We invented NVLink. That was 10 years ago now.
Rip NVLink
cuDNN,
on consumer side.
TensorRT, Nickel. We bought Mellanox, TensorRT LM, the Triton inference server. And all of it came together on a brand new computer nobody understood. Nobody asked for it, nobody understood it, and in fact, I was certain nobody wanted to buy it. And so we announced
I'm wondering
it at
how right
GTC,
the Matrix is going to be.
and OpenAI, a small company in San Francisco,
It's
saw
going
it.
to take a while, but
They asked me to deliver one to them. I delivered the first DGX, the world's first AI
there's
supercomputer
Elon Musky boy.
to OpenAI in 2016. Well, after that, we continued to scale. From one AI supercomputer, one AI appliance, we scaled it up to large supercomputers, even larger. By 2017, the world discovered transformers.
I want
that
to
we
see
could
one of
train
these someday.
Enormous amounts of data
They can
and
upscale Earth.
recognize and learn patterns that are sequential.
Dude,
over
imagine if we
large
could see twice the
spans of
frame
time.
rate. That'd be crazy.
It is now possible for us to train these large language models to
'Cause right now we can only see
understand and
24
achieve a
frames, so-
breakthrough in natural language understanding.
Imagine we saw 48 frames IRL. That's
And
wild.
we kept going after that. We built even larger ones. And then in November 2022, trained on thousands, tens of thousands of NVIDIA GPUs in a very large AI supercomputer, OpenAI announced ChatGPT.
The new
1
OpenAI stuff is
million
wild.
users after 5 days.
It is.
1 million after 5 days, 100 million after 2 months. The fastest growing application in history.
Do you hear the
And
AIs
reason
just
for that
talking
is
to
very
each other?
simple.
It's like if you
It
put
is just
Google
so
Assistant
easy
and
to
Siri
use,
next to each other
and
and
it
they're
was
talking
so
to each other, but
magical to use.
not stupid.
To be able to interact with a computer like it's human. Instead of being clear about what you want. It's like the computer understands your meaning. It understands your intention. Oh, I think here it asks the closest night market. Night, as you know, the night market is very important to me. So when I was young, I was.
Yeah, I'm wondering
I
what.
think I was
Like
4.5
next year, I might
years old.
actually go to
I used to love
Computex.
going to the night market because I just love watching people. And,
This year, nah.
And so we went. My parents used to take us to the night market.
When he was young, dude,
圆环
Jensen's like 60, bro.
讲对吗？圆环，去吃蚵仔煎。And I love going. And one day, my face. You guys might see that I have a large scar on my face. My face was cut because somebody was washing their knife, and I was a little kid. But my memories of the night market is so deep because
Someone
of that.
tried to
And
kill
I
him,
used to
bro.
love- I still love.
He was
going to the
getting
night market.
assassinated when he
And
was
I
like
just need to tell
8.
you guys this: the Tonghua night market
Oh, man.
is really good because there's a lady. She's been working there for 43 years. She's the fruit lady, and it's in the middle of the street.
Oh, yeah, the fruit lady, yeah.
Between the two, go find her. Okay, she. 就赞呢，就赞呢，这喝假。
Don't harass. That's crazy.
She's really terrific. I think it would be
I
funny
guess.
after this, all of you go to see her. Every year she's doing better and better. Her card test has improved, and I just love watching her succeed. Anyways, ChatGPT came along. And,
You gotta think about it. He is kind of
something
yapping, but you think
is very
this is a
important in this
presentation for
slide.
the people that are there and not
let me
really
show
for the
you
live stream. This part, but
This slide, okay, and this slide. The fundamental difference is this.
that's pretty quick. It's pretty quick.
Until ChatGPT revealed it to the world, AI was all about perception, natural language understanding, computer vision, speech recognition. It's all about perception and detection. This was the first time the world saw a generative AI. It produced tokens,
Yeah, it's like simulating the
One
fruits
token
for
at
the
a
fruit
time.
lady.
and those tokens
That's why
were
she keeps
words.
getting better because
Some of the tokens, of course, could now
she's
be
been simulating.
images, or charts, or tables,
min-maxing.
songs, words, speech, videos. Those tokens could be anything. Anything that you can learn the meaning of. It could be tokens of chemicals, tokens of proteins, genes.
Yeah, it's
You
like they
saw
took
earlier
ChatGPT.
in Earth 2,
They said,
we
hey,
were
we need a
generating
presentation that's going to be like an
tokens
hour and a half.
of the weather. We can learn physics.
As
If you
much
can
padding
learn
as possible.
Physics, you could teach an AI model physics. The AI model could learn the meaning of physics, and it can generate physics. We were scaling down to 1 kilometer, not by using filtering, it was generating. And so we can use this method to generate tokens for almost anything of value. We can generate steering wheel control for a car.
It is crazy.
We can generate articulation for a robotic
I would say that
arm.
like I'd love to see generative physics in a
Everything
game,
that we can learn,
but then at the same
we can
time,
now generate.
I think
We
physics
have
are already
now
pretty good in a game.
arrived, not
It's
at
good
the
for
AI
simulation.
era, but a generative AI era. But what's really important is this. This computer that started out as a supercomputer has now evolved into a data center, and it produces one thing. It produces tokens. It's an AI
It's
factory.
like Chuck E. Cheese.
This AI factory is generating, creating, producing something of great value, a new commodity. In the late 1890s,
There's part of
Nikola
the Copilot,
Tesla invented an AC
Microsoft Copilot that
generator.
I actually like.
We invented
I think it has
an
potential.
AI generator. The AC generator generated electrons. NVIDIA's
down a bit.
AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily.
It's like I know
Every
they're being
single
invented,
industry
but
is
what are
now
we using it
piling
for
on.
right now?
For the very first time,
How long is it going to
the
take to
IT
state that we
industry,
actually
which is $3 trillion,
use AI to a point that it
$3
matters?
trillion IT industry is about to create something that can directly serve $100 trillion of industry. No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry. This is going to be a manufacturing industry, not a manufacturing industry of computers.
Hey, bro, you can put some Subway surfers on the screen for yourself. You know,
this has never happened before. Quite an extraordinary thing. What started with accelerated computing, led to AI, led to generative AI, and now
ChatGPT clutch for college based.
Now the impact.
My friend genuinely used
our industry
ChatGPT in college and like was easily getting through some essays.
A new product we call tokens for many industries, but the impact to ours is also quite profound.
My only problem with like that, because it's based off of,
as I was saying earlier,
what people write,
years,
and there's going to be a point in time where
computing has been changed.
Like if it's always learning off of what people are writing and doing, it's not going to be thinking for itself at some point. Where the computer
needs instructions. Now
like
computers process LLMs,
like is it going to copy itself, or is it going to? I don't know.
And
it needs new information if people stop making stuff.
It's retrieval based. Almost every time you touch your phone, some pre-recorded
that'd be way
text
distant in the future.
or
People are still write shit
image
now,
or pre-recorded video is retrieved for you and recomposed based on a recommender system to present it to you based on your habits. But in the future, your computer will generate as much as possible, retrieve only what's necessary. And the reason for that is because generated data requires less energy.
I agree
to go fetch
to some point.
Generated data.
We also have a problem with bandwidth.
It will encode knowledge. It will code your
I don't know how we could make
instead of
our network
get that information
and like how we communicate with each other. I mean, we can get more bandwidth, but latency is like a fixed thing. Like I don't know how we get lower latency. I mean, maybe I don't know, but
that we use,
if we could generate more stuff on our side, then we could get better latency on the network.
It performs tasks, and instead of an industry that is producing software, which was a
and that could mean like cloud streaming and that kind of stuff. So basically, you own nothing, and you will be happy.
The idea that Microsoft created for packaging software revolutionized the PC industry. Without packaged software, what would we use the PC to do? It drove this industry. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMS, Nvidia Inference Microservices.
He talked about this in March, I think.
What happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large, billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs, tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism, expert parallelism, all kinds of parallelism, distributing the workload across multiple GPUs, processing it as fast as possible, because if you are in a factory, if you run a factory, your throughput directly correlates to your revenue.
I'm wondering if he's going to save a big announcement for the end.
Correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company.
I doubt the 59 would be happening yet.
Realize that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it containers an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT, Triton for inference services. It is cloud native so that you could auto scale in a Kubernetes environment. It has management services and hooks so that you can monitor your AIs. It has common APIs, standard APIs, so that you
Gamers
can
made
literally
AI and still get no
chat with this
True.
box. You download this NIM, and you can talk to it. So
What if we
long
get a
as
4060
you have CUDA
Super?
on your computer, which is now, of
We
course,
need a 4060
everywhere. It's in
Super,
every
actually.
cloud, available from every computer maker. It is available in hundreds of millions of PCs. When you download this, you have an AI, and you can chat with
It'd
it
be
like
late, though.
ChatGPT. All of the software is now integrated. 400 dependencies all integrated into one. We tested this NIM, each one of these pre-trained models, against our entire install base that's in the cloud, all the different versions of Pascal and Amperes and Hoppers and all kinds of different versions. I even forget some. NIMS. Incredible
I would have
invention.
thought
This is one of
if
my
he had
favorites.
something, he would have announced
And
it
of
earlier.
course, as you know, we now have the ability to create large language models and pre-trained models of all kinds.
That was crazy.
And we have
I feel like they like to
all of
talk
these
about this a lot.
various
Something about
versions,
AI.
whether it's language-based or vision-based or imaging-based, or we have versions that are available for healthcare, digital biology. We have versions
Bro, this Jensen
that
is
are
not
digital
it, bro.
humans
This is
that
not
I'll
it.
talk to you about. And the way you use this, just come to ai.nvidia.com. And today we just posted up in Hugging Face the Llama 3 NIM, fully optimized.
They put it in their
available there for you
URL.
to try, and you can even take it with you. It's available to you for free. And so you could run it in the cloud, run it in any cloud.
That's crazy.
You could download this container, put it into your own data center, and you could host it, make it available for your customers.
Looking like a Funko Pop.
We have, as I mentioned, all kinds of different domains. Physics, some of it is for semantic retrieval called RAGs, vision languages, all kinds of different languages. And the way that you use it is connecting these microservices into large applications. One of the most important applications in the coming future, of course, is customer service agents. Customer service agents are necessary in just about every single industry. It represents trillions of dollars.
Man, bro, I'm tired,
customer
bro.
service around the
We're
world.
like 3 hours.
Nurses are customer service agents in some ways. Some of them are non-prescription or non-diagnostics based nurses are essentially customer service. Customer service for retail, for quick
He's
service,
just night to
foods,
sleep based.
financial services, insurance. Just tens and tens of millions of customer service can now be augmented by.
I think literally what he's
language
saying
models
is like
and
customer service
augmented
jobs, like,
by
hey, we don't
AI.
need them.
And so these boxes that you see are
replacing
basically
people.
NIMs. Some of the
I
NIMs
think
are
that's literally
reasoning
what he just
agents.
said.
Given a task, figure out what the mission is, break it down into a plan.
Brother.
Some of the NIMs
That's
retrieve
crazy.
information. Some of the
Wait,
NIMs
someone donated. I
might,
never saw that. When did that happen?
Go and do search. Some of the NIMs might use a tool
Well, thanks,
like
Lucas.
co-op that I was talking about earlier.
I have no clue when that
Could
was.
use
It's
a
not
tool
even in
that,
history.
Could be running on SAP, and so it has to learn a particular language called ABAP. Maybe some NIMs have to do SQL queries, and so all of these NIMs
Like, hey,
are
we're replacing
experts
everybody. It's starting
that are
now.
now assembled as a team. So what's happening? The application layer has been changed. What used to be
At least they're saying
applications
it.
written with instructions
At least they're
are
saying it,
now
bro.
applications that are assembling teams of AIs.
Oh, yeah.
Very few people know how to write programs. Almost everybody knows how to break down a problem and assemble teams. Every company, I believe, in the future will have a large collection of NIMs, and you would bring down the experts that you want. You connect them into a team, and you don't even have to figure out exactly how to connect them. You just give the mission to an agent, to a NIM to figure out
Bro, what?
who to break the tasks down and who to give
So
it
are
to.
they saying that we're not going to program anymore? Like,
that central the leader of
what
the,
I've heard,
of
and
the
there,
application,
I
if
could
you will,
definitely
the
see.
leader of the team would break
I'm gonna turn
down the
him down a
task
little bit.
and give it to the various team members. The team members would do their performance.
What I've heard
bring it back
from
to the
people
team
is
leader.
that
The team leader
AI
would reason about
can
that,
write programs,
present
but is not that
information back to you.
efficient right now. And usually you need
Like
somebody to write it in order to break it down. So maybe we could use an AI to get us started on writing programs, and then we could
interact with these
start,
these
and then we
AI
could actually like
services
optimize it and all that kind of
text prompts,
stuff.
speech prompts,
But apparently AI is not that good yet. Maybe it'll get good, but
where we would like to
I think it's a
interact
jumping off
with
point at the moment.
what is otherwise a human-like form. We call them digital humans. Nvidia has been working on digital human technology for some time. Let me show it to you.
Nim sounds like a
And
Minecraft animal.
Before I do that, hang on a second. Before I do that, okay, digital humans has the potential of being a great interactive agent with you. They make much more engaging.
So he's
they
talking
can
about
be much
AI
more
girlfriends right now.
empathetic.
Yeah.
And of course, we have to cross this incredible chasm, this uncanny chasm of realism, so that
Oh yeah,
the
it's
digital
humans too.
humans would appear much more natural. This is, of course, our vision. This is a vision of where we love to go. But let me show you where we are.
Oh, God,
Great
it's
to be in
creepy.
Taiwan. Before I head out to
Oh,
the night
God.
market, let's dive into
Oh,
some
God.
exciting frontiers of digital humans.
Imagine a future where computers interact with us just
That's
like
Jensen.
humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
They will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
we have generated several design options for you to choose from.
They'll also be AI customer service agents, making the
That's my
interaction more
microphone.
engaging and personal.
I'm so
Or
unsettled,
digital
bro.
healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medications?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And they'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of
Wait, that
digital
was an
humans
AI?
are AI models built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
你们部落有什么特别的习俗吗？
我们有丰富的
Oh,
祭
God.
祀仪式和传统舞蹈，还有对大自然
Oh
的
god,
崇
that's
拜。
actual AI girlfriend. That's
The
crazy.
AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering
That
to
does look
simulate the
pretty
way
good.
light penetrates
But there's
the
something
skin, scatters,
There's
and
something that's
exits
just a
at
little
various
bit off
points,
about it that's throwing me
giving
off.
skin its soft and translucent appearance. Nvidia
Those
Ace
look good, though.
is a suite of digital human technologies packaged as easy to deploy, fully optimized microservices or NIMs. Developers can integrate Ace NIMs into their existing frameworks, engines, and digital human experiences.
What are they saying that you
Nemotron
could put this in a
SLM
game?
and LLM NIMs
Just like
to
from the
understand
NIM?
our intent and orchestrate
They don't need that
other
much
models.
work.
Riva speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial
Oh,
and
this is gonna
body
be coming to
animation.
games at some point,
And
like
Omniverse
mainstream.
RTX with
Some point,
DLSS
man.
for neural rendering of skin and hair. Ace NIMs run on Nvidia GDN, a global network of Nvidia accelerated infrastructure that delivers low latency digital human processing to over 100 regions.
好吗？
10 years from now, it's real. Probably. What's up, Ghosty?
Pretty incredible. Well, those ACE runs in the cloud, but it also runs on PCs. We had the good wisdom of including Tensor Core GPUs in all of RTX. So we've been shipping AI.
That's the thing is, Nvidia
GPUs
has the infrastructure for this. They've been doing.
Preparing
People are
ourselves
just
for
getting
this day.
NPUs. Nvidia
The
has
reason for
had
that is very simple. We always
AI
knew
on
that in
like,
order to create a new
consumer
computing
stuff
platform,
since 2018.
you need an install base first. Eventually, the application will come. If you don't create the install base, how could the application come? And so, if you build it, they might not come. But if you don't build it, they cannot come. And so we installed every single RTX GPU with Tensor Core processing, and now we have 100 million GeForce RTX AI PCs in the world, and we're shipping 200. And this Computex, we're featuring 4 new amazing laptops. All of them are able to run AI. Your future laptop, your future PC will become an AI. It'll be constantly helping you, assisting you in the background. The PC will also run applications that are enhanced by AI. Of course, all your photo editing,
I still
your
think
writing,
AI is
your
mainly
tools,
just a tool.
all the things that you use will all be enhanced by AI. And
for a while.
your PC will also host applications.
My laptop will be
with
able to
digital
code.
humans that are AIs. And so there are different ways that AIs will manifest themselves and become used in PCs, but PCs will become very important AI platform. And so where do we go from here?
Mm-hmm.
I spoke earlier
Yeah,
about the
graph go
scaling
up.
of
Just
our
like
data
Nvidia
centers.
stock
Every
price.
single time we scaled, we found a new phase change. When we scaled from DGX into large AI supercomputers, we enabled transformers to be able to train on enormously large data sets. Well, what happened was, in the beginning, the data was human supervised. It required human labeling to train AIs. Unfortunately, there is only so much you
Now
can
AIs
human
can
label.
train AIs.
Transformers made
It's
it
like a
possible
AI
for unsupervised
centipede.
learning to happen. Now, transformers just look at an enormous amount of data, or look at an enormous amount of video, or look at an enormous amount of images, and it can learn from studying an enormous amount of data, find the patterns and relationships itself. Well, the next generation of AI needs to be physically based. Most of the AIs today don't understand the laws of physics. It's not grounded in the
And this how
physical
Terminator
world.
started? Yeah, I think
In
so.
order for us to generate images,
Do we
and
go down
videos
Terminator route
and
or do we go
3D
down
graphics
Matrix route?
and many physics phenomenons.
Two different
we need
ways.
AIs that are physically based and understand the laws of physics. Well, the way that you could do that is, of course, learning from video is one source. Another way is synthetic data, simulation data. And another way is using computers to learn with each other. This is really no different than using AlphaGo, having AlphaGo play itself.
This is how they take
Self-play,
over.
And between the two capabilities,
This is how AI takes
same
over.
capabilities, playing each other for a
When they
very
start
long
talking
period
to
of
each
time,
other.
they
we're
emerge
fucked.
even smarter. And so you're going to start to see this type of AI emerging. Well, if the AI data is
They're going to make their own large
synthetically
language model.
generated and using reinforcement learning, it stands to reason that the rate of data generation will continue to advance. And every single time data generation grows, the amount of computation that we have to offer needs to grow with it. We are about to enter a phase where AIs can learn the laws of physics and understand and be grounded in physical world data. And so we expect that
This is before
models will
Computex.
continue to grow. And we need larger GPUs. Well, Blackwell was designed for this generation. This is Blackwell, and has several very
Okay.
important technologies. One, of course, is just the size
They
of the
announced
chip.
Blackwell back in
we
March.
took two of the largest, a chip that is as large as you can make it. at
New chips for
TSMC,
GPUs
and
are
we
going to be on
connected
Blackwell.
two of them together with a 10
Let's see.
terabytes per second link between. The world's most advanced SerDes connecting these two together. We then put two of them on a computer node, connected
Their
with
architecture
a Gray
is
CPU. The Gray
insane on
CPU
server
could be
side,
used
by
for
the way.
several things.
It
In
costs
the
just as
training
insane as it sounds,
situation,
but
it could be used
yeah,
for fast
it is
checkpoint
wild.
and restart. In the case of inference and generation, it could be used for storing context memory so that the AI has memory and understands the context of the conversation you would like to have. It's our second generation
I get that, but it's also
engine.
creepy.
Transformer engine allows us to adapt dynamically to a lower precision based on the precision and the range necessary for that layer of computation. This is our second generation GPU that has secure AI, so that you could ask your service providers
per second
to protect your AI from being either stolen, from theft, or tampering. This is our fifth generation NVLink. NVLink allows us to connect multiple GPUs together, and I'll show you more of that in a second. And this is also
what's interesting is Nvidia uses NVLink to connect their GPUs together, but they also like Intel's talking about using Ethernet to connect GPUs together.
Flip-flop, memory on
I want to
chip,
see how these pan
memory
out.
off chip, so that we can, in the field, determine whether a particular chip is
Because Ethernet can get really
failing.
fast.
The MTBF, the mean time between failure of a supercomputer with 10,000 GPUs, is measured in hours. The mean time between failure of a supercomputer with 100,000 GPUs is measured in minutes. And so the ability for a supercomputer to run for a long period of time and train a model that could last for several months is practically impossible if we don't invent technologies to enhance its reliability. Reliability would, of course, enhance its uptime, which
Yeah, I still
directly
can't
affects the
imagine
cost.
buying a server,
And then lastly, decompression
making an
engine. Data
entire
processing is one
server
of the
system
most
for like
important things we
$100
have to
million,
do.
and then
We added a data compression engine, decompression
it's
engine, so
irrelevant
that we can pull data out of storage
in like a year.
20 times faster than what's possible today. Well, all of this represents Blackwell, and I think we have one here that's in production. During GTC, I showed you Blackwell in a prototype state.
Dude, they're so cool. Like these like platforms come
other
up
side?
from underneath the stage. It's so badass.
This is why we practice.
That's on the other
在
side.
美国就是这样子的。
There's gonna be a lady that hands it to him, and it's like her job is on the line as she hands it to him.
Ladies and gentlemen, this is Blackwell.
Jesus. God damn. God damn. Look how big
Blackwell
those
is in
chips are.
production.
Holy shit.
Incredible amounts of technology.
Oh, that's
This is our
wild.
production board.
That's a thick
This is
boy.
the most complex, highest performance computer the world's ever
Remember,
made.
this is an ARM CPU that Nvidia
This is the
collaborated
gray
with ARM
CPU.
to make.
And these are.
And they can make
You can
CPUs.
see each one of these
See
Blackwell
when that comes to
dies,
consumer
two of them
size.
connected together. You see that? It is the largest die, the largest chip the world makes. And then we connect two of them together with a 10 terabyte per second link.
Boys are fat.
Okay, and that makes the Blackwell computer. And the performance is incredible. Take a look at
I
this.
would hope so.
So,
But next year it's gonna be irrelevant.
you see our
Big graph, go bigger.
the
Check it out.
computational, the flops.
Check out Moore's
the
Law
AI
dead.
flops, for
Blackwell.
each generation
Woo.
has increased by 1,000 times in 8 years. Moore's Law in 8 years is something along the lines of, I don't know, maybe 40, 60.
He said this like
And
last
in
year.
the last 8 years, Moore's Law has gone a lot less. And so, just to compare, even Moore's Law at its best of times compared to what Blackwell could do. So the amount of computations is incredible. And whenever we bring the computation high, the thing that happens is the cost goes down. And I'll show you. What we've done is we've increased, through
The
its
more they buy, the more they
computational
save.
capability, the energy used to train a GPT-4, 2 trillion parameter, 8 trillion tokens. The amount of energy that is used has gone down by 350 times. Well, Pascal would have taken 1,000
Yeah, you thought your
gigawatt
13900K
1,000
used
gigawatt
a lot
hours
of power.
means that it would take
Wonder how much
a
these guys go.
gigawatt data center. The world doesn't have a gigawatt data center, but if you had a gigawatt data center, it would take a month. If you had a 100 megawatt data center,
that doesn't
it would
even
take
sound
about
real.
a year. And so nobody would, of course, create such a thing, and that's the reason why these large language models, ChatGPT, wasn't possible only 8 years ago. By us driving down increasing the performance, the energy efficient, while keeping and improving energy efficiency along the way.
He's kind of quiet, by the way.
With Blackwell, what used to be 1,000 gigawatt hours to 3, an incredible advance. 3 gigawatt hours. If it's a
I don't even know how much power I use.
A 10,000 GPUs, for example, it would only take 10,000 GPUs.
I'm probably using like 150 watts right now.
10 days or so. So the amount of advance in just 8 years is incredible. Well, this is...
That's like watts. That's no gigawatt.
Token generation. Our token generation performance has made it possible for us to drive the energy down by 45,000 times. 17,000 joules per token. That was Pascal. 17,000 joules is kind of like 2 light bulbs running for 2 days. It would take 2 light bulbs running for 2 days amounts of energy, 200 watts running for 2 days, to generate 1 token of GPT-4. It takes about 3 tokens to generate 1 word. And so the amount of energy used necessary for Pascal to generate GPT-4 and have a ChatGPT experience with you was practically impossible. But now we only use 0.4 joules per token, and we can generate tokens at incredible rates and very little energy. Okay, so
that's cool, though.
Blackwell is just an enormous leap. Well, even so, it's not big enough. And so we have to build even larger machines. And so the way that we build it is called DGX.
Yeah, I'll use Hellblade 2 for benchmarks,
this is our
of course.
Blackwell chips, and it goes into DGX systems.
He's lost again.
That's why we should practice.
Somebody's getting fired today.
This is a DGX Blackwell. This is air-cooled, has 8 of these GPUs inside.
Oh, man.
Look at the size of the heat sinks on these GPUs. About 15 kilowatts, 15,000 watts.
Is it the same price, or does it cost twice as much, but half the size?
This supports x86, and it goes into the infrastructure that we've been shipping hoppers into. However, if you would like to have liquid cooling, we have a new system, and this new system is based on this board, and we call it MGX for modular. And this modular system, you won't be able to see this. Can they see this? Can you see this?
No.
You can?
Yes.
Are you?
No. I don't know what bro's pointing at.
I say.
Those are some racks,
so this
you know?
is the MGX system, and here's
nice
the
looking
2
racks right there.
Blackwell board. So this one
What is that? A
node has
single U?
4
Like, how do
Blackwell
these work?
chips.
It's like a one.
These 4 Blackwell
how
chips.
servers work.
This is liquid cooled.
The single U. That is like
9 of them. 9 of them. Well, 72 of these GPUs. 72 of these GPUs are then connected together with a new NVLink. This is NVLink switch 5th generation. And the NVLink switch is a technology miracle.
Is on
this is
this
the most
one.
advanced switch the world's ever made. The data rate is insane.
And look, they have like ports to put the liquid
and these
through.
switches connect
for water
every single
cooling.
one of these Blackwells to each other.
Mm.
So that we have one giant 72 GPU Blackwell. Well, the benefit of this is that in one domain, one GPU domain,
NVLink
this
ain't
now
never
looks
come
like
back.
one GPU. This
Dude, what if
one
they announced the
GPU has
Nintendo
72
Switch?
versus
Nah,
the last generation of 8, so we increased it by 9 times. The amount of bandwidth we've increased by 18 times. The AI flops we've increased by 45 times.
The AI
and yet the amount of
flops.
power is only 10 times. This is
Bro, whoever decided that
kilowatts,
flops was going to be a good
that is
acronym.
10 kilowatts. And that's for one. Now, of course, well, you could always connect more of these together, and I'll show you how to do that in a second. But what's the miracle is this chip, this NVLink chip. People are starting to awaken to the importance of this NVLink chip as it connects all these different GPUs together, because the large language models are so large, it doesn't fit on just one
No,
GPU.
50 series probably isn't going to be announced here.
It's going to take the
I'd be
entire rack
surprised.
of GPUs, like
I'd
this
be
new
surprised.
DGX that I was just standing next to hold a large language model that are tens of trillions of parameters large. NVLink switch in itself is a technology miracle. It's 50 billion transistors, 74 ports at 400 gigabits each, 4 links, cross-sectional bandwidth of 7.2 terabytes per second. But one of the important things is that it has mathematics inside the switch so that we can do reductions, which is really important in deep learning, right on the chip. And so this is what a DGX looks like now. And a lot of people ask us,
How heavy do you think that thing is?
you know, they say,
Can you deadlift it?
There's this confusion about what NVIDIA does, and how is it possible that NVIDIA became so big building GPUs?
I'm
So
telling
there's an
you, bro,
impression that
these
this is
things
what
are
a GPU
freaking
looks like.
huge, bro.
Now,
I can't
this
show it
is
to you
a
right now because
GPU.
in my
This is one of
computer.
the most advanced GPUs
Oh
in the
my
world.
God.
This is a gamer GPU.
There's a gamer
You and I
one.
know that this is what a GPU looks like. This is one GPU. Ladies and gentlemen,
Rip.
DGX GPU.
That's a 4080 Super.
You know?
Remember gamers?
The back of this GPU is the NVLink spine. The NVLink spine is
I just slot that
5,000
bitch into your
wires,
computer.
2 miles.
That's literally him just saying they ain't a gaming company no
And
more.
it's right here.
It's part of their business. Still like, what?
This
A quarter of their
is
revenue,
an
but
NVLink
shit.
spine. And it connects
Listen a
72
moment.
GPUs to each other.
Damn.
This is a electrical, mechanical
Imagine slotting
miracle.
72
The
4090s
transceivers
together.
makes it possible for us to drive the entire
think you could finally run
length
past
in
Jersey?
copper. And as a result, this switch, the NVLink switch, driving the NVLink spine in copper, makes it possible for us to save 20 kilowatts in one rack. 20 kilowatts could now be used for processing. Just an incredible achievement. So this is the
That's
NVLink
cool, though.
spine.
That's how the RTX 59. Pretty much.
I went down today. And even this is not big enough. Even this is not big enough for AI factories, so we have to connect it all together with very high-speed networking. Well, we have 2 types of networking. We have InfiniBand, which has been used in supercomputing and AI factories all over the world. And it is growing incredibly fast for us. However, not every data center can handle InfiniBand because they've already invested their ecosystem in Ethernet for too long. And it does take some specialty and some expertise to manage InfiniBand.
So I think they're talking about switching over to NVLink
and so
for
what we've
people.
done is we've brought the capabilities of
companies.
InfiniBand to the Ethernet architecture, which is incredibly hard. And the reason for that is this. Ethernet
Bro,
was
if you thought you were going to
designed
50 series
for
announcement, bro,
high
you're wrong.
Average throughput. Because every single node,
He basically
every single
just said
computer
that
is
he doesn't
connected to a
care about the
different
gaming
processor on the
GPU.
Internet, and most of the communications is the data center with somebody on the other side of the internet. However, deep learning and AI factories, the GPUs are not communicating with people on the internet mostly, it's communicating with each other. They're communicating with each other because they're collecting partial products, and they have to reduce it and then redistribute it. Chunks of partial products, reduction, redistribution. That traffic is incredibly bursty. And it is not the average throughput that matters, it's the last arrival that matters. Because if you're reducing, collecting partial products from everybody, if I'm trying to take all of your
mean, they still care. But if Jensen's going to go to an event, do a conference, he's going to be talking about their moneymaker. He's going to be talking about this.
It's whoever gives me the answer last. Okay? Ethernet has
Gaming
no
still makes a
provision
lot of money for him.
And so there are several things that we had to create. We created an end-to-end architecture so that the NIC and the switch can communicate. And we applied 4 different technologies to make this possible. Number 1, Nvidia has the world's most advanced RDMA. And so now we have the ability to have a network level RDMA.
I think he's speaking Mandarin every now and then.
That is incredibly great. Number 2, we have congestion control. The switch does telemetry at all times incredibly fast. And whenever the GPUs or the NICs are sending too much information, we can tell them to back off so that it doesn't create hotspots. Number 3, adaptive routing. Ethernet needs to transmit and receive in order.
It's not a bad GPU. It's just a little overpriced, I think.
Or we see ports that
I wish
are
they had
not
12 gigs
currently being
too.
used. Irrespective of
It doesn't
the
like
ordering,
need
we
it,
will
but
send it to the
I wish it
available
did.
ports, and Bluefield on the other end reorders it so that it comes back in order. That adaptive routing, incredibly powerful. And then lastly, noise isolation. There's more than one model being trained or something happening in the data center at all times, and their noise and their traffic could get into each other and causes jitter. And so when the noise of one training model,
yeah, this is a significant problem.
The last arrival to end up too late.
Like if you have so much computing in one place,
well, overall,
there's going to be like crosstalk, and there's going to be things, there's going to be
a
issues.
$5 billion or $3 billion data center, and you're using this for training. If the utilization, network utilization, was
There's so much data.
40% lower, and as a result, the training time was 20% longer. The $5 billion data center is effectively like a $6 billion data center. So the cost is incredible. The cost impact is quite high.
That's the thing, is like at the $300 price point, at least
with
in
Spectrum
the
X
US,
basically allows us
and
to
the 7600 and the 4060
is
they're about the same
so this is
performance.
Really
I would just buy the 4060.
We have a whole pipeline of Ethernet products
because
behind us.
they're really not that different in price either.
X800
Like $30 difference.
51.2 terabits per second and 256 radix. The next one coming is 512 radix, is 1 year from now. 512 radix.
Well, it's just a missed opportunity from AMD.
X800 Ultra, and the one after that is X1600.
Because Nvidia definitely doesn't have a competitive GPU there, and then AMD just gives the least competition
is
possible.
Designed for tens of thousands of GPUs. X800 Ultra is designed for hundreds of thousands of GPUs. And X1600 is designed for millions of GPUs. The days of millions of GPU data centers are coming. And the reason for that is very simple. Of course, we want to train much larger models, but very importantly, in the future, almost every interaction you have with the internet or with a computer will likely have a generative AI running in the cloud somewhere. And that generative AI is working with you, interacting with you, generating videos or images or text or maybe a digital human. And so you're interacting with your computer almost all the time, and there's always a generative AI connected to that.
Do you think we'd ever go back to having multiple GPUs?
A lot of it could be in the cloud. These generative AIs will also do a lot of reasoning capability. Instead of
on the
just
consumer side
answers, they might
to me,
iterate on answers.
with how much talk there is of data centers, like, dude, it wouldn't surprise me if, like, 10 years down the line, if there's a huge push and a lot of people are going to cloud computing.
Let's take a look at all of this put together.
Like, not even having,
tonight,
like,
this is
PCs.
Our first nighttime keynote. I want to thank all of you for coming out tonight at 7 o'clock.
That was Gordon from PC World, I think.
What I'm about to show you has a new vibe.
I'll have to look at that again.
There's a new vibe. This is kind of the nighttime keynote vibe. So enjoy this.
Yeah, this is like nighttime for them. This is like 8 o'clock over there.
Blackwell.
they already show this?
Go, go, go. Okay.
Pretty sure we saw this just without music. It's like lower res too or something. Why didn't they AI upscale it? Like, come on. Yeah, we couldn't just saw this without music before. Do you think this is AI music?
Let's go.
Let's go. The entire song is just ad-libs. Did she say the more you buy, the more you save? It's in another language, but what the hell? It's a rave.
Now you can't do that on a morning keynote.
No, the guy just looks like
I think
Gordon.
that style of keynote has never been done in Computex ever. Might be the last.
Bro, what? This is his own thing.
Only
yeah,
Nvidia can pull off that.
Yeah.
Only I could do that.
Sure. I guess musicians are safe from AI. Have you heard actually some of the
Blackwell,
AI
of
songs?
course,
Similar?
is the first generation of Nvidia platforms that was launched at the beginning, right as the world knows the generative AI era is here. Just as the world realized the importance of AI factories, just as the beginning of this new industrial revolution. We have so much support. Nearly every OEM, every computer maker, every CSP, every GPU cloud, sovereign clouds, even telecommunication companies, enterprises all over the world. The amount of success, the amount of adoption, the amount of enthusiasm for Blackwell is just really off the charts, and I want to thank everybody for that. We're not stopping there. During the time of this incredible growth, we want to make sure that we continue to enhance performance, continue to drive down
Bro,
cost,
the YouTube emotes are
cost of training, cost of inference, and continue to scale out AI capabilities for every company to embrace. The further performance we drive up, the greater the cost decline. Hopper platform, of course, was the most successful data center processor probably in history. And this is just an incredible success story. However, Blackwell is here, and every single platform, as you'll notice, are several things. You got the CPU, you have the GPU.
Can I have my own emotes to
switch.
YouTube live streams? I don't even know.
The NVLink switch connects all of the GPUs together as large of a domain as we can, and whatever we can't do, we connect it with very large and very high-speed switches. Every single generation, as you'll see, is not just a GPU, but it's an entire platform. We build the entire platform. We integrate the entire platform into an AI factory supercomputer. However, then we disaggregate it and offer it to the world.
Better
and
TTV.
the reason for that is because all of you could create interesting and innovative configurations and all kinds of different
I don't want to stream on Twitch because I have no Twitch presence at all.
Data centers and different customers in different places, some of it for edge, some of it for telco. All of the different innovation are possible if we made the systems open and make it possible for you to innovate.
Let me see if I can turn them up a bit more.
So we design it integrated, but we offer it to you disintegrated so that you could create modular systems. The Blackwell platform is here. Our company is on a 1-year rhythm.
He's louder now.
Our basic philosophy is very simple. 1, build the entire data center scale, disaggregate it, and sell it to you in parts on a 1-year rhythm, and we push everything to technology limits. Whatever TSMC process technology will push it to the absolute
All this
limits.
is riding on
Whatever packaging
TSMC.
technology, push it to the absolute limits. Whatever memory technology, push it to absolute limits. SerDes technology, optics technology, everything is pushed
What
to the
is
limit.
that emote?
Well, and then after that, do everything in such a way so that all of our software runs on this entire install base. Software inertia is the single most important thing in computers. When a computer is backwards compatible and is architecturally compatible with all the software that has already been created, your ability to go to market is so much faster. And so the velocity is incredible when we can take advantage of the entire install base of software that's already been created. Well, Blackwell is here. Next year is Blackwell Ultra. Just as we had H100 and H200, you'll probably see some pretty exciting new generation from us for Blackwell Ultra. Again, pushed to the limits. And the next generation Spectrum switches I mentioned. Well, this is the very first time that this next click has been made. And I'm not sure yet whether I'm going to regret this or not.
Oh, man.
We have
I do
code
like
names in our
the red
company,
one, though.
And
Sick.
we try to keep them very secret. Oftentimes, most of the employees don't even know. But our next generation platform is called Rubin. The Rubin platform.
They're already announcing their next one?
I'm not going to spend much time on it.
I have heard that they're planning on doing basically like every year release cycles on data centers.
So we have the Rubin platform, and 1 year later we have the Rubin Ultra platform. All of these chips that I'm showing you here are all in full development, 100% of them. And the rhythm is 1 year at the limits of technology, all 100% architecturally compatible. So this is basically what NVIDIA is building, and all of the richness of software on top of it. So in a lot of ways, the last 12 years,
did you see
from
most
that
like AI generated
of ImageNet, and us realizing that the future of computing was going to radically change to today, is really exactly as I was holding up earlier. GeForce pre-2012 and NVIDIA today.
What is this one?
The company has really transformed tremendously, and I want to thank all of our partners here for supporting us every step along the way. This is the NVIDIA Blackwell platform. Let me talk about what's next.
It's just great that they already announced the next one.
The next wave of AI is physical AI. AI that understands the laws of physics. AI that can work among us. And so they have to understand.
God, dude, that still like triggers my mind. It just like awakens.
How to interpret the world, how to perceive the world. They have to, of course, have excellent cognitive capabilities so they can understand us, understand what we asked, and perform the tasks. In the future, robotics is a much more pervasive idea. Of course, when I say robotics, there's a
would AI be good or bad at
Among
Us?
The representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate
I think AI
robots.
might cook, I ain't gonna lie.
And those robots will be building products that are robotic. Robots
we just study the movements of other players,
building products
systematically
that
hunt them
robotic.
down and kill them.
Well, in order for us to do that, we need to make some breakthroughs. And let me show you the video.
You wouldn't be able to tell when they're lying.
The era of robotics has arrived. One day, everything that moves will be autonomous. Researchers and companies around the world are developing robots powered by physical AI. Physical AIs are models that can understand instructions and autonomously perform complex tasks in the real world. Multimodal LLMs are breakthroughs that enable robots to learn, perceive, and understand the world around them and plan how they'll act.
Oh god, that was the new Pringles can.
Human demonstrations, robots can now learn the skills required to interact with the world using gross and fine motor skills.
Boing.
One of the integral technologies for advancing robotics is reinforcement learning. Just as
word.
LLMs need RLHF, or reinforcement learning from human feedback, to learn particular skills, generative physical AI can learn skills using reinforcement learning from physics feedback in a simulated
Is it doing
world.
this in like real time?
These simulation environments
I feel like
are
it's
where
not real
robots
time.
learn to make decisions by performing actions in a virtual world that obeys the laws of physics. In these robot gyms,
Oh yeah, this is
a
where the
robot
AI robots
can learn
fight
to
each other.
perform complex and dynamic tasks safely and quickly, refining their skills through millions of acts of trial and error. We built Nvidia Omniverse as the
Amazon.
operating system
Yay,
where physical AIs
Amazon.
can be created. Omniverse is a development platform for virtual world simulation, combining
Remember when
real-time,
Amazon was going to try the
physically-based
drones
rendering,
flying packages to people?
physics simulation,
That did not
and
happen.
generative AI technologies. In Omniverse, robots can learn how to be robots. They learn how to autonomously manipulate objects with precision, such as grasping and handling objects, or navigate environments autonomously, finding optimal paths
Look at these
while
NPCs.
avoiding obstacles and hazards.
And the Roombas.
Learning in Omniverse minimizes the sim-to-real gap and maximizes the transfer of learned
I
behavior.
do agree with this. Like, if you're going to train an
Building
AI,
robots
you
with
should
generative
train it
physical AI
in a
requires
program
three
and not in
computers.
real life because it's going to take
NVIDIA
up
AI
space and time.
supercomputers to train the models. NVIDIA Jetson Orin and next generation Jetson Thor robotic
The drones are
supercomputer
drones
to
are
run the
real
models.
for Amazon.
And NVIDIA Omniverse, where robots can learn and refine their skills in
It still
simulated
happen.
worlds.
Has to be like small packages, right?
We build the platforms, acceleration libraries, and AI models.
Yeah,
needed
if you're
by
on
developers
anything,
and companies,
guys, if you're on
and allow them to
anything,
use any
turn it down.
or all
Anything
of
on
the stacks that suit them best.
coding, electronic
wave
kind of
of
stuff,
AI is
if you're in that field, I would
Robotics,
definitely
powered by
recommend
physical AI,
picking up
will
some physical
revolutionize
skills
industries.
and stuff that not everybody can do. Like, I have a lot of remodeling experience. I don't think AIs are going to be walking into people's houses and remodeling
This isn't the
for a long
future.
time.
This is happening now. There are several ways that we're going to serve the market. The first, we're going to create platforms for each type of robotic systems. One for robotic factories and warehouses.
Oh, yeah.
One for
I mean, I don't
robots
think OnlyFans
that manipulate things. One for
have
robots
that much longer
move,
against AI
and one
either.
for robots that are humanoid. And so each
Just
one
saying.
of these robotics platform is like almost everything else we do: a computer, acceleration libraries, and pre-trained models. Computers, acceleration libraries, pre-trained models. And we test everything, we train everything, and integrate everything inside Omniverse, where Omniverse is, as the video was saying, where robots learn how to be robots. Now, of course,
Yeah.
the ecosystem
And then
of robotic
AI
warehouses
trains
is
AI.
really, really complex. It takes a lot of
It's
companies,
over, boys.
a lot of tools,
We're
a lot of
cooked.
technology to build a modern warehouse. And warehouses are increasingly robotic. One of these days will be fully robotic. And so in each one of these ecosystems, we have SDKs and APIs that are connected into the software industry, SDKs and APIs connected into edge AI industry and companies, and then also, of course, systems that are designed for PLCs and robotic systems for the ODMs. It's then integrated by integrators created for ultimately
I remember when they first showed
building
off
warehouses,
Omniverse, and I really
for
didn't think it was like
Here
anything.
we have an example of Kenmac building a robotic warehouse for Giant Group.
Good morning. Is this a stream? Okay, it looked choppy.
Okay, and then here, now let's talk about factories.
What was that?
Factories has a completely different ecosystem. And Foxconn is building some of the world's
What were
most
the Roombas
advanced
cooking?
factories. Their ecosystem, again, edge computers and robotics, software for designing the factories, the workflows, programming the robots, and of course, PLC computers that orchestrate the digital factories and the AI factories. We have SDKs that are connected into each one of these ecosystems as well. This is happening all over Taiwan. Foxconn is building digital twins of their factories. Delta is building digital
Have any of you
twins
guys
of their
been to
factories.
Taiwan? Like, how advanced
By the way,
is
half is real,
Taiwan?
half
Is it
is
like a first world
digital,
country
half is
or
Omniverse.
what?
Pegatron is building digital
We're
twins.
gonna end up like that game.
of
Remember
their
me?
robotic factories. Wistron is building digital twins.
I have
of
no
their
clue what Taiwan is like.
robotic factories. And this is really cool. This is a video of Foxconn's new factory. Let's take a look.
Demand for NVIDIA accelerated computing is skyrocketing as the world
AI.
modernizes traditional data centers
Wait, this
into
is an
generative AI factories.
This is an AI avatar.
Foxconn, the world's largest electronics manufacturer, is gearing up to meet this demand by building robotic factories with NVIDIA Omniverse and AI. Factory planners use Omniverse to integrate facility and equipment data from leading industry applications like Siemens Teamcenter X and Autodesk Revit. In the digital twin, they optimize floor layout and line configurations and locate optimal camera placements to monitor future operations with NVIDIA Metropolis-powered Vision AI. Virtual integration
The NPCs
saves
walking around
planners
just
on the
kills me.
enormous cost of physical change orders.
Share
During
price go boom.
construction, the Foxconn teams use the digital twin as the source of truth to
Apple Vision
communicate
Pro.
and validate accurate
Isn't
equipment
the Apple
layout.
Vision Pro like? Are they struggling to move
The
units?
Omniverse digital twin
Who wants that?
is also the robot gym, where Foxconn developers train and test NVIDIA Isaac AI applications for robotic perception and manipulation, and Metropolis AI applications for sensor fusion. In Omniverse, Foxconn simulates 2 robot AIs before deploying runtimes to Jetson computers. On the assembly line, they simulate Isaac manipulator libraries and AI models for automated optical inspection for object identification, defect detection, and trajectory planning.
I think the video is upscaled.
To transfer HGX systems to the test pods, they simulate Isaac
think
perceptor-powered
it's a low res.
Ferrobot AMRs as they perceive and move about their environment with 3D
This could
mapping
be relevant
and
to
reconstruction.
gamers. I don't exactly know how,
With
but
Omniverse, Foxconn builds their robotic factories that orchestrate robots running on NVIDIA Isaac to build NVIDIA AI supercomputers.
they could test like physics
which in
and
turn
stuff. I think.
Train Foxconn's
I don't know.
robots.
There's probably something. Roombas are gonna be sick now. I thought this guy was Gordon.
So, a robotic factory is designed with 3 computers. Train the AI on NVIDIA
Dude,
AI.
it's a Lego
You have
Jensen.
the robot
Wow.
running on the PLC systems for orchestrating the factories, and then you of course simulate everything inside Omniverse. Well, the robotic arm and the robotic AMRs are also the same way, 3 computer systems. The difference is the 2 Omniverses will come together. So they'll share one virtual space.
Oh, it's like
When they
Earth
share
1 and Earth
virtual
2
space,
combining together, right?
that robotic arm will become inside the robotic factory. And again, 3 computers. and
Where's
we
that robot
provide
arm going?
The computer, the acceleration layers, and pre-trained AI models. We've connected NVIDIA
The hell is
Manipulator and NVIDIA Omniverse with Siemens, the world's leading industrial
Bro,
automation
why do they call
software
it
and systems
Siemens?
company. This is really a fantastic partnership, and they're working on factories all over the world. Semantic
So I feel
Pick
like
AI
sometimes-
now integrates Isaac Manipulator.
I feel like sometimes
and
you gotta
Semantic
think about
Pick
the
AI,
acronym.
Operates ABB.
You gotta think
KUKA,
about it. I guess like, hey
Yaskawa,
guys, this one ain't gonna work.
Universal Robotics, and TechMan.
That doesn't
And so
matter if it's the last name. I don't give a
is
shit.
A fantastic integration. We have all kinds of other integrations. Let's take a look.
Okay.
ArcBest is integrating Isaac Perceptor into Fox Smart autonomy robots for enhanced object recognition and human motion tracking in material handling. BYD Electronics is integrating Isaac Manipulator and Perceptor into their AI
It's
robots
odd that they did the
to
one
enhance manufacturing efficiencies for global
in Chinese earlier, but now it's English.
Idealworks is building Isaac Perceptor into their IWOS software for AI
By the way, I
robots
think
for
this
factory
is an
logistics.
AI
Intrinsic, an
Jensen
Alphabet
talking.
company, is adopting Isaac Manipulator into their
Doesn't sound
flow state
bad.
platform to advance robot grasping. Gideon is integrating Isaac Perceptor into Tray AI-powered forklifts to advance AI.
This is like a satisfying TikTok, bro.
Argo Robotics is adopting Isaac
Look at the little
Perceptor
robots
into
working.
perception engine for advanced vision-based AMRs. Solomon is using Isaac Manipulator AI models in their AccuPick 3D software for industrial manipulation.
How are they sticking
Techman
to
Robot is adopting Isaac Sim and
little suction
Manipulator
cups?
into TM-Flow, accelerating
Goodbye,
automated optical
forklift drivers.
inspection.
Maybe.
Teradyne Robotics is integrating Isaac Manipulator into Polyscope X for cobots and Isaac Perceptor into Mir AMRs. Vention is integrating Isaac Manipulator into Machine Logic for AI manipulation robots.
Robotics is here. Physical AI is here. This is not science fiction, and it's being used all over Taiwan, and just really, really exciting. And that's the factory, the robots inside, and of course, all the products are going to be robotics. So there are two very high-volume robotics products. One, of course, is the self-driving car, or cars that have a great deal of autonomous capability.
Dude, I don't even know
the entire stack. Next year, we're going to go
when
to
automatic
production with
self-driving cars are going
Mercedes
to come
fleet,
around.
And after that, in 2026,
Because
the JLR fleet.
I feel like there would be a point when all cars should just be self-driving. Like it's either all of them are self-driving or none of them are self-driving, because the ones that are in between could have problems. But if all of them are self-driving, they can communicate with each other.
Robotic factories with
So-
robots inside will likely be humanoid robots. And this has great progress in recent years in both the cognitive capability because of foundation
Is this
models
IRL?
and also the world understanding capability that we're in
It
the
looks
process of
like real
developing.
life.
I'm really excited about this area because obviously the easiest robot to adapt into the world are humanoid robots because we built the world for us. We also have the most amount of data to train these robots than other types of robots because we have the
this
same
Groot.
Physique. And
Or is
so
it
the amount of training data we can provide through
GR00T? I don't know which one it is. I didn't hear what
capabilities
it
and
said.
video capabilities is going to be really great. And so we're going to see a lot of progress in this area. Well, I think we have some robots that we'd like to welcome. Here we go. About my size.
We don't need cars on Earth too.
And we have
This is-
some friends to join us.
This one looks
So
funny,
future,
bro.
the future of robotics is here. The next wave of AI.
Oh, they got the
And-
boys.
And of course,
Whole gang.
Taiwan builds computers with keyboards. You build computers for your pocket. You build computers for data centers in the cloud. In the future, you're going
That's
to
kinda
build
cute.
computers that walk and computers that roll, around. And so these are all just computers. And as it turns out, the technology is very similar to the technology of building all of the other computers that you already built today. So this is going to be a really extraordinary journey for us. Well, I want to thank. I want to. I've made one last video, if you don't mind. Something that.
Oh yeah, he made it, right?
We really enjoyed making.
Like the self-driving toilet. What the hell? That looks cool.
台湾帮助我们实现了一个愿景，在这条漫长的路上，
So
无数的
apparently this
伙
is
伴支
Chinese
持着我们，
Jensen in AI.
从加速运算、电脑绘图、科
just-
学研究到
maybe
人
it's
工
him, I
智
don't know,
慧的
bro.
高峰。每一个晶片，每一台电脑，都描写着你们辛勤工作
These are AI
和追
generated.
求完美的故事。
Or at least
台湾是无
well,
名的英雄，确实世界的
this is
支柱
AI.
一起，我们推动了产业的复兴，辛勤的耕耘，让我们能够踏入占新运算的领域。其中，我们制作的电脑会转化成新型的工厂，制造珍贵无比的人工智慧。亲爱的伙伴们，你们是 AI 产业革新的后盾。 无论面对多大的风浪，你始终稳如磐石。科技的卓越、勤奋与齐心合力的精神，是你的超能力。
It's accurate. Okay.
没有你，我们的
can't speak
愿
Chinese.
景只是一
I
个
know.
无法实现的梦想。
Crazy concept.
与你同行
Never would have thought.
我们勇往直前，创造智慧与便利的生活，对抗疾病
It's like little
和自
suction
然
cups.
灾害，让我们的世界变得更美好。谢谢你，台湾。让我们继续为这段 AI 创新之旅打造一个成功
This is
和
trippy.
繁荣的产业。
Things just kind of like morph into each other. They talked about data center
大家
GPUs.
谢谢 ，Thank you. I love you guys. Thank you. 大家谢谢。
Wish Taiwan was real. Taiwan is not a country.
Thank you all for coming. Have a great Computex. Thank you.
I am here at Computex. I will make you like me best. Yeah, sing it with me.
They remixed it.
Like Nvidia.
Why is it worse now? It's worse. Boys, they literally made it worse.
Once again at Computex, we will show you all our best. Yeah, digital twins and names with Nvidia. To all our friends in Taiwan, we hope that you like this.
It is so bad.
Yeah, so good luck from AI, and Nvidia.
Why is this word? Like, the song was better before. I agree, the beat's kind of cool. That's like, ugh. So basically, they didn't really say that much for us. I mean, there's maybe the AI. This is just gonna end. Okay, this is probably copyright. I'm gonna not do that. The biggest thing that I think I would see from this is probably, God, with the NIMS. God, when did they do that? When was that, guys? When they had the NIMS that were like generating people, I could see people doing that. Like I could see that being in games, you know. One sec. Let's see if I can find it. I mean, it was cringy, but it was also like, oh yeah, I could see this being in games at some point in time. Where the hell was it? Wasn't it like here? Yeah.
Finally, AI models that reproduce lifelike appearances, enabling real-time path tracing.
I think this could be something at some point. Like, this is building to something. Is it there yet? No. How long is it going to take people to integrate this in games? It's probably going to be a while. But with this, like, brother, they're getting closer and closer to
built on multilingual speech recognition
AI girlfriends, so
and LLM
that's a W, right?
Generate conversation.
你们部落有什么特别的习俗吗？
我们有丰富的祭祀仪式和传统舞蹈。
I know, right? Dude, there was that one line, it was like that reproduce. Dude, when the AIs start reproducing, we are fucked. We are fucked.
还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And
I mean, like that will be practical at some point. Like, just imagine, like, you know how like there is kind of like a rudimentary way to like quickly do lip syncing in games where they just like they don't have to mocap the entire thing. They can just kind of make the mouth match the volume of the sound. They can do that kind of stuff. But imagine like there's an AI that actually matches the voice line to the thing, and then it automatically does all that shit. Like it would make games that have like realistic facial movements like a lot faster to make. I could see that being a big thing, because honestly, I don't think games should be investing in a ton of money of animating faces, because that takes forever. It's expensive, and most people don't really care. So they can make it even faster and more high quality. Cool. I think that'd be useful. Omniverse, they talked about it towards the end. I think could be good for simulating game environments and physics and stuff more quickly, because it's like a thing like that. And then you could try to replicate the same thing in a game engine. And also seeing maybe what kinds of physics would be cool to have in a game, because basically Omniverse is a system where they can simulate basically anything you want, as far as you know. Thanks, Michael. You might have not noticed that they put NIMS on Hugging Face. You can download it and all that. Isn't that the one thing? Like, I feel like people made like these AI characters in games and they were able to talk to them. Isn't that? Is that from NIMS? I'm going, Mark. But yeah, there isn't too much for like games in this. I didn't expect anything different. I don't think this is a big show for them. I would think the next big show is going to be building up to the release of the actual GPUs for gaming. And they also did announce, where was that at? They announced their new data center line, which is Rubin. They just kind of casually dropped that. It's supposed to come out next year, so Blackwell is going to be relevant already. Gamescom. Yeah, I could probably see that.
The next one coming is...
Next one coming. He said "come" a lot in this, which is kind of odd. And then, yeah, they announced Rubin. Obviously, this doesn't matter for us, but unless it matters if GPU architecture for consumer side is based on Rubin, then maybe. But it probably doesn't matter for us. They might even skip like we have Blackwell. They might make Rubin for data center, and then they're gonna have another one for everyone else. RTX 59 will be used in making games, not playing. That's an interesting concept. I mean, yeah, but people are still gonna buy it. People will always buy the expensive shit. Bet your money on that. Well, I mean, there really wasn't that much to it. So I think I'm gonna try to make it. AMD's got their announcement or their conference today. Oh, they actually have chat. That's kind of interesting. Nvidia didn't have chat on their live stream. But they're probably announcing a Ryzen 9000 series. So I'm probably going to be streaming this later today. It's at 9:30 p.m. So right now it's 9:05 a.m. So it's in 12 hours from now. But I'm probably gonna stream that too. But yeah, I don't see that much. During this presentation. You guys got anything to say? Other than that, I'm probably gonna end up ending the streamer. RTX 5000 series probably ain't coming until later this year. Bro, is it? I kept seeing this guy. I swear this looks like Gordon from PC World. Let me look him up. PC world. Aloha from Hawaii. Aloha. I ain't never been to Hawaii. It kind of looks like Gordon. I don't think it's him though. This is him. Because
AMD products, the current announced into
where? Yeah, he's not there. It just looks like him, bro. I'm just tripped out. It's very similar. He's not that because he's on this stream. That's him. He actually has some hair right now. He didn't shave it. How excited for AI are you? Honestly, I don't really use it for anything other than upscaling in games sometimes. And like if we're talking about new AI, I mean, we use like basic AI like all the time, like on Google or search. Like people say like algorithms, but AI has been around for a while. Like these algorithms are smart. And they do like study like what you watch and everything to try to personalize your content. So if we're not talking about that kind of stuff, that is AI. I just don't use it for anything. So I don't know if I should be excited. I need to see something that's good. So I guess we'll see. I'm not a hater of it. But yeah, like in this, when we start seeing the AIs reproducing, then we're fucked though. And they're training each other. Oh yeah, we're fucked. They're gonna take over Earth too. Also, probably the highlight of this is that Nvidia made Earth 2.
Disasters, or better understand the impact of climate change so that we can adapt better, so that we could change our habits now.
Earth 2,
This
bro.
digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year. But this year, we made some great breakthroughs. Let's take a look.
Earth 2, bro. Oh my god. That's insane. Nvidia completely lost in the AI thoughts. Siemens. Dude, there was some shit in that, bro. There is some shit in that. Oh, god. Yeah, I'm waiting for the new patch for Earth, the DLC. Yeah, it was mostly just yapping. You didn't miss too much. I figured I'd stream it just in case there is something. I wasn't expecting too much though. So a lot of calm in that stream. Yeah, there was, bro. It was weird. All right, guys, I'm gonna wrap it up. And I'll be on later to do the AMD one as well. So hopefully that announcement's gonna be pretty cool. I'm excited for Ryzen 9000 series. So, yeah, I guess some good quotes for Jensen. By the way, like uploads have been a little slow on the channel, mainly because I'm working on that bathroom that's above me here. It's a lot. It's like 8 to 10 hour days. So I just have not had time. So, but I am working on stuff in the background. I just gotta find the time to do it. So I just want to let you guys know, and things will pick up pretty soon. Almost done. Done with that bathroom. All right. Yeah, I pick up a lot of viewers from Nvidia. All right, see you guys. Have a good one. Peace.